Let's see. Let's get our chats going. Nice one bite. Yeah. All right. I'm gonna try to solve it. Yeah. He's always putting these good. What are they called? Yeah, they're challenge questions is what I call them. Or yeah, they're math competition questions. I think it's from Waterloo. He wants to get involved with doing them again. Here, let me get the TikTok chat working. Why is YouTube just like never working these days? Does this one work? There we go. Nice. Okay, cool. Beautiful. Get better soon. I just recovered. Yeah, there's something going around for sure. That's annoying. I mean, yeah, that's what I meant to say.
It's happening in Europe as well.
Is it, Naroski? Oh no.
Yeah, I'm also sick. Yeah.
God damn it. It's like,
Everybody's sick, I guess.
Everyone's getting sick, I guess. Yeah, it's annoying because I have to go like fly on Wednesday. I gotta go fly out to go see my family, and I'm gonna be sick.
Okay.
Or I don't know. I think I got sick probably Friday, and my body's been reacting to it not terribly badly. It's just annoying. My head is fuzzy, my nose is runny, and my throat hurts.
Yeah, it's the same. It was the same for me. Like I'm on my second day, and yeah, I'm just like, it's annoying sick. Like you just cough and sneeze, and that's it.
Yeah.
Disqualified.
It's just fucking annoying. I'm just like, what? This virus isn't even doing anything.
Surprise, motherfucker.
Like, can I either get me bedridden or don't do anything?
Yeah, because the problem is that like I'm half expected to still do things. If I was like violently sick right now, I would just cancel the stream. But the problem is like I can still stream because I'm not bedridden. I'm just annoyed. I'm annoyed.
Exactly.
That's too funny. All right, let's see what's in the. What's up, Bamboo? Good to see you. I don't think it touched Canada yet. It probably froze on the way to Canada. I don't know. All right, here we go. The cold is crazy. Long time no yeah, what's up, Bamboo? How's it going, dude? I don't know if that works. Does that command work? I don't think that command works. Followage? Yeah. We used to have a bot that would do it. Okay, let's see. Naroski has a solution, which is great. I'm going to try to... I don't think any of those commands work. Yeah, I need to set them up. Or they worked at some point. I can't tell. All the Twitch bots are always fucking crazy. Okay. A lock code is made up of 4 digits that satisfy the following rules. It's about to be 1 year. Great. Oh, there you go. Yeah. Oh, you can also like click on the user. Yeah, that's the best way to do it. At least 1 digit is a 4, but neither the second nor the 4th digit is a 4. Exactly 1 digit is a 2, but the first digit is not a 2. Exactly 1 digit is a 7. The code includes a 1, or the code includes a 6, or the code includes 2 4s? Oh, man. How many possible codes are there? Okay. I don't know, I think how I tackle these, which could be wrong. Roski, you can tell me if I'm doing it wrong, but like I like to like come up with like combinations and stuff, maybe. Like little trees.
Yeah, if you want, I can give you a starting hint.
Yeah, give me a starting hint. Yeah. Give me the starting hint.
So if you want to look at the top, I made a statement that we know that every code contains a 2 and a 7.
Oh, how do I know every code contains a 2? Okay, because exactly 1 digit is a 2, and exactly 1 digit is a 7. Oh, very cool. Okay.
Yeah, we don't know where they are, but we know that we have them everywhere.
Okay.
Like in every case, we
a
have
2 or
a
a
7.
7. Okay.
And a 7. Simultaneously.
So maybe do we consider cases where like there's a 7 here, and then where could the 2 be? Is that kind of how we do it?
Yeah, kind of.
All right, let me try to do it, because I see this. Every code contains a 2 or a 7, so then it's kind of a question of whenever I have these slots, I think about, okay, what's a case of like this slot has to equal this. Every case also has a 4. Oh, interesting. At least 1 digit is a 4. Oh, that's cool.
And a 4, yeah.
Oh, I didn't see that. A 2 or a 7 or a 4. Okay. But then there's some restrictions, right? What's up, JC? Right, the second digit can't be a 4, and the 4th digit can't be a 4. Oh, fascinating. Okay. So maybe I consider like what the first digit can be. The first digit can't be 2. Oh. But it could be anything else in between. Well, actually, wait a minute. We've actually really narrowed things down here, haven't we, Narosky? Because I get to pick 4 numbers, right?
Yeah.
But I already know that what 3 of them have to be, right? And
yeah, so I would what I would do now is I would look at what the rules are telling me one by one.
exactly. Okay.
Right. So it's important that you follow them like exactly as they say.
Do you think sequentially is very important? What's up, Adarsh?
I think they are put in that order for a reason.
For a reason, okay. At least one digit is
Yeah.
4, but neither the second digit nor the fourth digit is 4. Okay. So in my mind, there's only 2 options for the 4. It's either here or it's here. And I guess it could include it twice. So maybe let's come up with, I could have 4xxx, or I could have xx4x, right? Or I could have 2 4s apparently. That can happen.
Yeah. So
But
you can treat it as 2 different cases.
I think like 3 different cases, right? Oh, I guess you're saying the one case is that there is 1 4, and the second case is that there are 2 4s?
Yeah, and I think the one where there are 2 4s is the easiest one.
This is the easiest one for sure, right? Because if there's 2 4s, right, I need a 2 and a 7 as well, exactly. Right? But, okay, and the first digit can't be a 2. Well, obviously, that's fine. And then, right, because the 4 can only be on the first and the third, and it has to be there somewhere. Okay. So, okay.
Yeah.
And I need a 2 or a 7. So we can either have 4 2 4 7 or 4 7 4 2. Right?
Yep.
Yeah. Okay, cool. All right. We got 2 combos.
Good job.
That's cool. Okay. I like that. You're right. That was the easiest one. Okay, but now these get harder. Okay. Exactly 1 digit is a 2, but the first digit is not a 2. Well, that's already the case here, right? So,
I mostly am looking at the fourth rule because the first 3 ones to me seem like instructions on how to treat the cases that the 4th rule gives you.
Got you. Okay, I see. These are like the 3 different things, right? I either have 2 4s.
Yeah.
I have one where it's a 6, right? So I either have like 2 7 4 6 or I have 2 7 4 1. Right?
For example, yeah.
Yeah. But there's no restrictions on the 1s and the 6s. Yeah.
Yeah. So that's why I think yeah.
So it's just about where
cases on those ones.
Oh, okay. So it's just case. So I would say that right. So that's going to double whatever possibilities I get here, right? Because then I can do it with a 1 or I can then do it with a 6. So let me just think about where I put the 2s and the 7s, right? So this is, and there's no restriction on it. Oh, okay. So isn't that just 3 choose 2? For like where I place the 2s and the 7s for this one?
Sure, yeah. For if the 4 is the first.
If 4 is the first one, there's 3 choose 2 ways of me putting
no,
the.
actually, no. I
or
think
it's 3 permutation 2. Sorry.
Yeah.
Yeah. Yeah. It's not 3 choose 2 because the order does matter. The order matters. Yeah. Yeah. Okay. So this is 3p2 ways to place the 2 and the 7, and that's the same thing here, right? 3p2. So actually, this is kind of like this is useless. Whatever. It just means I double the number of permutations I have. Yeah. Okay.
Well, no, I disagree.
You disagree? Okay.
So, if 4 is the first digit,
yes,
right? The remaining digits are 1, 2, and 7.
Oh, I see. I can't put the 2 here.
You're not that guy, pal. Trust me. You're not that guy.
You're right. Okay.
You
are right.
Put the 2
you
as
are
the
right.
first digit.
Thank you. Yeah, chat's right. Chat's right. Narowski's right. You're right. Okay, so we'll come to that later. This one's a little bit more complicated. -1, Jason. Jason says. Yeah,
So,
okay.
yeah.
So there's 3p2 ways to place the
that's
2 and the
easiest
7. Or this one's the easiest one, you think?
No. The one where the 4 is the first one is the easiest.
Yeah. So there's 3p2 ways to choose place 2 or 7, and then you multiply that by 2 ways to fit the 1 and the 6, to fit the 1 or the 6, right?
Yeah, I think that's a way to think about it.
Okay. Yeah, let's think about that. Okay.
Because it doesn't matter because 1 and 6 has no restrictions.
So that's 3 factorial over 2 factorial. So 3 times 2 is 6. 6 over wait. 3 times 2.
Wait, no.
No, that's not how it works.
No, it's just 6 factorial, no?
Is it just 6 factorial? 3p2?
Yeah, isn't it? It's
Am I wrong?
3 factorial over 3 minus 2 factorial.
Oh, it's 3 minus 2. Okay. See, I thought it was the first one divided by the second one. You're right. Yeah. It's 3 factorial over.
Does order? Yeah. Does order even matter though?
For the 2 and the 7, yeah. Yeah, because I can either do 2 and 7 or 7 and 2. Technically, I picked 2 things, but the order does matter. Whether the 7 comes first or the 7 is second. Do you see what I'm saying?
Right.
You have
okay.
you have to pick 2 slots, but whether I pick this slot and then this slot, I'm just gonna assume like I place the 2 first and then I place the 7. So it matters whether I picked this, then I picked this, or I picked this and then I picked this. I think.
Yeah, fair enough. Yeah.
Okay.
So it's 3 over. So it's just 6. It's
6 times 2, so 12 combos here. Okay, I like that. Cool.
Yeah.
We're getting closer.
It's 3 minus 1 factorial, by the way. 3 minus 2 instead of.
Yeah, exactly. Yeah. Yeah. Okay. And then times 2 for the 6 and the 1. 6 and 1. 6 or 1. Placement. Yeah. Okay. All right. Well, now we gotta I think we gotta split this though. The first digit is not 2.
So let's just take one example. Let's say the code has a 1, so it's easier for us to think about it, right? So we have the digits 1, 2, 4, and 7, and we have the third digit as 4.
Yeah.
The first one can't be 2, right? So it must be 1 or 7, right?
1, 6, or 7, I think, right?
Yeah, but I said let's take a simpler example.
Oh,
so let's just take the case for 1 and.
Okay.
Right. So let's treat it separately. Is what I'm saying.
Okay. So what's the first case you want to consider? Sorry.
Yeah.
The first number is what?
No, the cases I'm thinking of is like if the code includes a 1 or the code.
I see. I got you. Because then we'll just double it. Got you. Okay. Got you. Okay. So here, let's say
exactly.
Got you. Code includes a 6. Okay. So then.
A 6.
So the first digit can be either a 6 or a 7.
Yeah.
6, 7. Damn it. Okay. 6 or 7. Fine. Okay. And then the next digit could be a 2. Well, I guess it kind of has to be a 2. Right? It could be a well, okay, now this is curious. There's 2 choices here, but then once we pick a 6 or a 7 for here, then this could be a 2 or a 6 or a 7, right? And then this could be a 2 or a 6 or a 7, but they're exclusive. Oh man, wait, let me think.
So it's not that difficult to think about it because if you fix a single digit, right? How many left do you have? You have 2 digits to fit.
Oh, I see. I can either
spot.
put a 7 here or a 2 here, or a 2 here or a 7 here. If I fix this to be a 6, right?
If you fix it, yeah.
Oh, I see.
So
okay.
How many would you get from that? You just
4.
Get 2.
Right,
you
get
2 factorial,
right.
example.
So you get two for it if it's a 6 first, and then you get another 2 if it's a 7 first, right?
And you multiply them, yeah.
So 4, right? Yeah.
So 4,
So-
yeah.
Okay.
It's this is this is as like a learning example. This is misleading because 2 plus 2 is equal to 2 times 2.
Right. I always
It's
hate this
important
dude.
that we multiply.
Yeah, 2 times 2
Yeah.
is different than 2 to the 2, which is different than 2 plus 2.
Yeah. In this case, we have to multiply the choices,
Yeah. Okay.
right? So
Okay.
It's 2 times 2.
All right. Second and fourth digit is either a 2 or like 6, 7. So times 2, so that's 4 choices. Okay. And that's if it-
And
that's
times
if it-
2 again.
And then times 2 again, because we're going to say like, oh, but what if it included a 1? Right.
Yeah.
Oh, this is kind of cool. Okay, so that's 8, right?
Yeah.
Okay, so then 12 combos plus
So-
8 combos plus 2 combos should be
plus
22.
2 combos.
Is it 22?
It's what I got as well.
Oh, okay. That's convenient. Shantrix is the answer to 22. This was Narowski's solution. Yes! Nice, good, great, we did it. Yay! Okay, let me see, like, your solution looks a lot more elegant than mine. Let me see. Oh, and then Shantrick posted the actual
Well,
solutions.
I did skip a lot of steps. Yeah.
No, I appreciate the hints. The hints really helped. Because I think more than anything, you want to teach a process, right? And so hints kind of force your brain to come up with the neural pathways to like come up with your own understanding of like how that process works. Yeah. Okay.
Yeah,
Let's
true.
see. Yeah. Okay. We know every code consists of 2 and a 7. Yeah. And then right, and you could have the case where there was 2 4s, and the case where there's 1 4. I see. Yeah. See, I understand it now because I did it. I think if I looked at this right off the bat, I wouldn't understand it. But because we
Yeah.
kind of walked through the thinking, I see where it's coming from. Yeah, it was 22, Arya. Isn't that crazy? I see. If it's the first one, sure, this was easy. 6 codes. Can't be a 2. 2 times 2. Yeah, cool. All right, cool. Same as that, but 10 codes, 22. Yeah, look at this solution. This solution's ugly, dude. What? My brain just like shuts off when I see this many words on a solution. I just like I don't want to read it.
Yeah, like this is pointless. Like, it's a math question and you have a math solution. Why do you type an
Yeah.
essay out?
Yeah, why did you
Like,
fucking type this
How do
essay?
you have the patience to do this? Yeah.
No, God! No, God, please, no!
Okay, cool. All right. Great question. Shantrix, thank you. Okay. Let's mark that one as done.
Nice.
Looks like Celine's next up. Where's Max? Max better show up. Max had a question about like the river and the things. And where's Max? I'm gonna tag his ass. They probably
I
aren't.
suppose I
Yeah.
answered. Yeah, I did answer them in general. It was like I thought about it for a second, and they already said they have everything they needed. So
Oh, you mean in the common area? Sorry.
yeah.
Oh, or you already helped out Max? Oh, nice. Okay. Uh-huh.
Yeah, I was expecting them to come along, but I suppose.
Yeah, we'll see. What's up? Potential. Oh, you're Celine. Celine, you're up next. We're gonna do your question, Celine. Yes. If you're watching us, the best way to go get help, like Celine did, like Shantrix did, go to this website, actualofficehours.com. And there, you can click on, the live queue shows like what questions we're doing. But put your username in, drop in a screenshot, hit upload. It'll get sent to us. We'll do it here on the stream. If you want to see what other questions are being done, you can just click here and see what's in the queue. There's only one question in the queue right now. It's a light Sunday.
If you want to have fun, I do have a lot of questions in the
We
channel.
will have fun. Yes. We can do a reprieve of what you were gonna do on Friday. That'll be fun.
Yeah, to make up for lost times.
Yeah, it's all
Yeah.
good. Yeah, it's okay. Let's do this one, and then if there's no questions, we'll just learn some fun Narowski math. I'm down. Sorry, and then let me upload this. Where is it? No. Where is my channel? There it is, Shantrix. Oh, download Shantrix. You pitched in a question? Nice, Starprod. Okay, cool. Someone was asking me about gravity. Someone said, do you know how to do gravity? Is that what I heard? Dude, why save Shantrix, please? There it is. Wow, that took forever. Good job. Shantrix. Okay. Let's see what we got next. From Celine. Ooh. Wow, we got a lot of fun stuff going on here. Okay. Is this kind of this reminds me of man, what was that shit called? Like Mad Libs? Where you're supposed to like figure things out and then there's like blanks and then they spell something out at the end. You know what I'm talking about? No. It was like the OG Cards Against Humanity, I guess. Okay.
The fact that we go from, I want to draw attention to this, the fact that we go from the first question being the total number of positive divisors of 2019
Yes.
to the integral of the absolute value of f of x minus g of x dx
Yeah.
is a testament to mathematics in America.
Oh, I see. Because we're eventually going to this. Yeah. Okay, so yeah, and then here's the thing.
This is, yeah.
So like apparently, and this is I guess the answer key is you're supposed to show that the number you got for this is less than this, which is less than this. This is less than this, less than this. I don't. Does anybody remember these things from like here math worksheet and then like it spells something at the end? That's what I'm talking about. Yeah, here, add and spell the hidden word. No one ever seen this shit? Oh well. I remember doing this in... What's up, Rampton?
How's it going?
Good. I was trying to... You remember those Gladiator? Yeah, right? Yeah. It was like, here, fill out the things, and then like, whatever the number was, if you got the number correct, it would like... It corresponded to a letter that would go down here, and then it would spell something, I don't know, like balloons or some shit. Yeah, those are fun. Yeah. I feel like this is another version of that, but it's just not fun because it doesn't spell anything. It just, I guess it's supposed to be true.
Just doing integrals?
Well, apparently this is a lot of things. This is kind of a tour de force of math, right? The number of positive divisors of 2019. Is 2019 prime?
Well, no, because 2 plus 1 plus 9 is 12, so it's divisible by 3.
Yeah, it's divisible by 3.
Oh, okay. See, y'all know all these cool little fun little math things. Okay.
Oh yeah, like 7 is the weird one. I never remember 7.
Yeah, I don't either.
Okay. So like, I know, is 1 technically a positive divisor? Does that count?
No, technically, I think. Actually, it does count. Yeah.
Does it count?
Yeah, we have a way of calling it in Romanian to differentiate it. I think it's proper divisor. I'm not sure.
Oh, proper. Well, 1 is definitely positive.
It's definitely positive, yes, but I'm not sure if they refer to it as.
Someone said 2 and 676. I don't think 2 and 676. Wait, what? 3? Yeah, you guys said that. Okay, if you add these numbers, then it's divisible. Yeah, it's divisible, right? Yeah, so 3 and 673. But then it's definitely not divisible by 5. And it's not divisible by 6 because it's not even. So I guess 7's the only other one to check, right?
7.
Right.
Well, 7.
That's 11. The weird one you guys are talking about, right?
Yeah.
Yeah.
I vaguely remember from my Olympiad days that 2019 was the year where everything was around primes. So I think 673 is a prime.
I think it
I
is too.
vaguely remember this fact.
Yeah. Okay, well, let's just let's.
Well, here's also another thing, which is like a little bit of like kind of introductory. If you are checking for primes,
Yeah.
right, the biggest prime that you have to check is the smallest number before the square root, right?
The smallest number.
So that's also another
yes. Oh, I see.
Yeah, or the prime right before the square root of. So like, I guess if we look up
Square root of 2019, like what that is?
square root 673, so it's 20. It's 25.9.
Okay.
So means that we have to check at max any prime that is smaller than 25. So
Oh,
which is 21.
interesting. Oh, this puts a limit on what
Or
the
sorry,
prime
not
number
21,
can be.
23. Sorry. Yeah.
Well,
So
right,
23.
because
So, like,
24 is not
the
prime.
biggest.
22 is not prime, but 23 is. Okay.
Yeah, and obviously if 20, like let's say if 29, which is a prime, if
Yeah.
that's a factor, then it has to get multiplied by a number smaller.
I see.
So you would obviously.
Oh, that's cool. That's a cool trick. That's a cool.
I feel
trick.
like it's one of those things in the math that when you know it, you're like, yeah, duh, but then
Yeah.
you don't do it until.
Yeah, you don't actually practice it. All right, that's cool.
Yeah.
Well, we know 673 is prime, so. So the number of positive divisors is that 4? Are there 4 positive
Yeah, I think
divisors?
that's 4.
Okay, cool. Okay. And then the whole sum of these divisors, well, that's kind of an ugly number. What? 2019 plus 673 plus 3 plus 1. 2696? Okay.
What is the? Oh yeah. I was about to ask, what is the whole sum?
I think they mean just adding these all up. But like, I don't know what the whole thing means.
No.
Like the entire sum, is that what they meant to say? Like you could say the sum. Celine, what is this? What is this, Celine, by the way? So,
Yeah.
Celine's the one that submitted it in our chat, Celine. Like this is such a funny hodgepodge of questions. I'm curious what it is. Okay. For the 3 points 0, 0, 3, 0, and 3, 4 in the xy plane, the equation of the angle bisector is y equals blank x. Don't you just divide the slope by 2 or something?
Yeah, this is just a 3, 4, 5, and then the slope would be
It's like
4 over
30.
3.
It's like, yeah, it's like 20. Yeah. Okay, so wait, 0, 0. Yeah, and then 3, 4. Right. Yeah, and so this is just a 3, 4, 5. Right, and then a is 3, 0.
Yeah.
Beautiful. Okay, cool. 4,
4.
3. So yeah, so the full slope would be 4 over 3. So the half slope or the bisector, yeah, it should be 4 over 6.
No, because you're doing half the slope, but it should be half the angle.
Oh,
I think. Wait,
Okay.
is half the? No, I don't think half the slope would
half
be
the slope
the
isn't half the angle.
No.
Oh, damn.
Yeah,
I was hoping it was.
because then you do the tan inverse, I believe, and then you have that.
And then that's not linear. Okay, gotcha.
Wait,
I see.
Yeah, because this one's y over x. Yeah, because y over x divided by 2 is not the same thing as 1 over 2 tan it.
Yeah, I got you.
I don't know how. Wait, is it? Does the half go into the tan inverse?
Well,
Is that a property?
Let's see. This is theta, right? And we're trying to figure out the equation of this line, I guess, right? Where this is theta over 2.
Yeah.
Okay. And then what I know is, right, yeah, so arctan of theta, or let me put the right color, sorry. Arctan of theta is equal to 4 over 3, right? And so I want to know
or tan of theta.
Sorry, yeah, right, sorry. Tan of theta is equal to that. And I want the tangent of theta over 2, right?
Yep.
Yeah.
Yeah.
Cool.
Yeah.
Because that
Which
would be
is just-
yeah. And is there an identity for this one? Do we know?
1 minus cos. Yeah, I know.
Okay.
Yeah, it's 1 minus cosine over sine.
Oh, okay. Yes. Okay, cool. Narowski's correct. Okay. Here, let me put this down here. Okay, yes. So 1 minus cos over sine, and
That's-
fascinating. Oh, but we know. Sorry, and this is the original triangle, though. Okay,
Yeah.
so this is
exactly.
1 minus 3 over 5, right? Over 4 over 5.
Yep.
Yeah.
Okay. So then this is 2 over 5 over 4 over 5. So it's equal to 1/2. It's pretty crazy. Yeah, so just y equals 1/2 x. I didn't know that.
Yeah, it would make sense. Yeah, which is not half.
Which is
Oh,
yeah,
fair enough. Yeah.
which is not 2/3.
Yeah, so it makes
Yeah.
sense. Yeah.
Okay, cool. Wow, we did that. Wow.
Yeah, it also makes sense because if this identity, if it was linear, then
Yeah, it should have been 4/6, but it's not. Okay, cool.
good thing you thought of that identity. I was gonna take the tan inverse back.
Yeah. Yeah, no. The only reason I thought about that is I'm literally doing a TikTok video on inverse trig functions, and one of them is a challenge of like doing 2 times tangent, and I'm like, oh wait, no. We don't have to actually get the angle. We can just make the triangle. Okay. For the parabola y equals x squared, the 2 points are on it. Its tangent line parallel to the line through the 2 points. Wait, what? Sorry, excuse me.
Wait, what?
Yeah, what is this even asking?
It's tangent line. Oh, okay. So you have to find the tangent line at a point that it's the same slope as the slope of these 2 points.
Oh, okay. Is this kind of like the
wording
the
of
mean,
this?
it's like the mean value theorem or something, right?
No, it's in Rolle's theorem.
Rolle's
which
theorem
is,
no Rolle's
is
theorem
like a subsection.
is a subsection
that
of the
Rolle's
mean
theorem?
yeah, Rolle's theorem is where the 2 points have the same y value, so you know the slope has to be
Intermediate
0. No, I think it's the mean value theorem. The intermediate value theorem is that if a function's continuous and you have like y equals 1 and y equals 4, that everything between 1 and 4 has to exist. I'm pretty sure.
Yeah, but what point?
Yeah,
does this have? Yeah.
Yeah, so this is the mean value theorem, right? Bless Paul. Wait, yeah, there you go.
Okay,
This
yeah. That's true. You're right.
Yeah. And that's what we're doing,
Which
right?
one is this? Is that mean value?
Yeah, this is the mean value theorem. And then you're right, Rolle's theorem is a subset of this.
Oh, yeah.
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 Again, I only know this because I've been doing videos on these recently. they I guess the way I remember that it's the mean value theorem is that it's the mean slope. It's like the average slope between 2 points. Yeah.
Oh, yeah, makes sense. Okay.
That's how I remember it, yeah. Okay,
I
so then
always like forget the name of these, but I'm like, oh, I know there's an identity.
yeah, right.
There's a theorem.
It's there somewhere. So this is y minus y over x minus x. So that's 8 over 4. It's equal to 2. Cool. Y equals 2x plus... I don't want to figure out the intercept. Fine. So that's 1 equals negative 2 plus b. B is equal to 3? I think so. Okay. So we need to figure out... Oh, and then this is easy, right? Because the tangent c, right, is y, so y prime, so dy dx.
I think the 3 that you found, is that supposed to be for the tangent line or for the line?
I think it's for the line. So its
that
tangent
line?
line is parallel to the line. Oh, wait a minute. Its tangent line is parallel to the line through the 2 points is the line. Dude, the wording is terrible.
Yeah, I think it's talking about the tangent line.
No, dude. Wait.
I've been dealing also with a lot of questions like this.
Dude, what the fuck is this wording, dude?
I don't know why they're wording it like this. Yeah, this is the
I'm having a stroke.
y-intercept of the tangent.
Okay. Its tangent
Yeah.
line parallel to the line of 3 points is the line whose point of tangency. Okay, fine. All right. Oh, okay. So we'll take this out. We do agree that it
Yeah.
has to be 2x though, at least, right?
Yeah, the 2 is that one.
All right, we're cool with that. And then the point would be, well, so that happens
so
at x equals 1, right?
It's just -1, no?
Yeah, which
Yeah.
is 1, 1.
Yeah.
Yes, right. So 1 is equal to 2 times 1. Narowski's right, plus b. So then this is just -1. Okay, cool. All right, we solved it. All right, great.
Yeah.
Rozzy says, hi, I finished my last ever math exam on Friday. Nice, dude. Congrats. I'm very proud of you.
Last ever math exam?
Dude, math never ends. Math never ends, dude.
Math never ends until...
Yeah, until death, maybe. Because if you have kids, you're going to end up having to do their math test, too. No. Never. I always think about that. It's kind of funny, like, when... And I want to, like, put this on my dating profile or something to be like, I got the kids once they get to, like, 12. Like, totally got them. Like, we don't need a tutor. We don't need anything. Like, I understand, like, the 12 to 18 demographic very, very well. Just get them to 12 for me. All right, let's see. When the line y equals m... Physics and Math Gladiator? Okay. Here, we'll just do the first page of these. I'm not going to do the second page. Because it's just going to take too much time or something. I don't know. There's, like, too much shit going on here. And I'm confused. I'm waiting for Celine to come back into the chat.
Can I see that last question?
Sure. Yeah.
I wanted to see, like...
It's on the queue as well.
Difficult.
Oh, it's not
F
diff-
of...
Yeah.
Oh, okay. It's just...
Maybe it's not. Maybe it's not.
No,
Okay.
It's not difficult.
All right, maybe we'll just do all of it. All right, here we go. All right, when the line y equals m x minus 5 plus 3 intersects the circle here, if and only if m is between 0 and this, and r is between this and this. Oh, this is kind of spicy. Okay.
So I guess you gotta...
I gotta, like, kind of draw this
Fine.
for me. Right, because it's 3 units up, but then it's shifted to the right by 5, right?
Yeah.
So it's really here, and then it's got some, like, mystery slope, right? It'd just be like whatever.
So we can. I think we can use the formula for the distance from the origin.
Which would be
To find
to find the minimum radius, you think?
Yeah, because
maximum
the
radius.
intersection.
The maximum radius.
No, minimum.
Yeah, because it would be like if the circle exceeds that point, that it's bigger than so it would always be.
Yeah.
So the radius of the circle, the biggest it can be, is at the point.
Because wait, what happens if it's bigger? Doesn't it still intersect here though? That's still cool.
Yeah, but it says intersects the point at r greater 0.
Yeah, so the radius has to be great.
That's also with.
Yeah, it's always gonna intersect.
Yeah, it's always gonna intersect then, right?
Oh, I thought it needs to be tangent to it. I don't know why.
No, that's from the other problem. Yeah.
Huh?
Yeah.
It's all good. Wait, isn't this just always? Isn't this always gonna intersect or something?
Yeah, but I think it's looking for the equation which it intersects it.
Oh wait. No, I think. Wait, you said that's the maximum radius, Narowski. Is that what you said, right?
So
I think I agree.
It's gonna be the minimum radius, and the minimum radius is going to be the distance from the origin to the line, and we have a formula for that.
Okay.
I think, does that make sense?
I'm trying to think
why the minimum though?
Why the
It'd
minimum?
be also smaller.
Yeah. What if it was smaller?
Because like Well, if
So the thing is smaller
It
than
still
it's
right,
intersects
right, Narowski? I can. So here's the thing. I think it can always intersect it, right? There's no way this line can never intersect this, right? Because I could just always have my slope just go in 360 degrees, right?
Yeah, but there is a certain angle you cannot get it. That's why I feel like it depends on the value of R.
I get it. So if this
Like
is
if you rotate this 90 degrees,
so if this is smaller than this, right? Now
Yeah.
suddenly there exist slopes that don't work, right? So for instance, this
Yes.
slope does not work, right?
yeah.
But
yeah.
yeah,
if you were bigger, right, than the point, then suddenly there don't exist any points. There exists. Suddenly all the slopes work, right?
right. Oh, so then
Yeah.
it must.
I think it's the
exactly
maximum.
distance from- yeah.
I think
It's
that's
the
the
maximum,
maximum.
yeah.
That's the maximum radius it can be. Yeah, I agree.
Yeah.
Yeah.
Yeah, okay. This question's weird.
Okay, yeah, fair enough.
You're having to
That's what-
solve for the negative space, right? Like the opposite,
Yeah.
because otherwise
So
there is no
R-
restriction.
Yeah.
So R has to be equal to. Oh wait, no, not R.
No, the distance, no?
I think equal to the distance. But then here's a.
Yeah.
When the actually, but this one says when the line intersects. Actually, that makes sense. Yeah, M smaller than. And then you have to find the point of tangent. Oh yeah, that's why you need the point of tangent. Because the
Yeah.
point of tangency is gonna be your maximum
Yes.
or minimum.
Oh well, Alistair is right. We can evaluate it.
We can't say M is negative.
Yeah, so we
Yeah,
can
but it
still
doesn't matter if
evaluate
it's negative,
it.
dude. Right? Because wait a minute. Oh, well maybe.
No, the point what Alistair is saying is we can evaluate it as m equals 0 to find the bound for the radius. So it's just going to be 3. So yeah, so the radius has to be 3.
Oh
wait.
yeah, that makes sense.
Wait.
That's
wait.
clever. Yeah, that's clever.
That's
Crazy.
true. Because there is a minimum that enforced by the problem.
Yes. Okay. I see. Right from here.
So this line can like kind of move, I guess, counterclockwise until
Yes.
it's vertical.
Correct.
And then when it starts to move the other way, then it becomes
The slope becomes negative.
so it becomes negative again. Yeah.
So this is the
So it's
point, right?
Yeah, so there's
and
a
then-
90-degree kind of
Like quadrant, right?
yeah.
That it can intersect at. If and only if. So what is this like infinity?
R is M 0 and wait, if we start to rotate it.
Wait, but they're saying if and only if it, so there has to be a case where
Oh,
like it
because
only
because the
works if it's
smallest si-
positive. Right?
R
Dude, this wording.
R should also have a range though.
I say that.
No, R I don't think R has a range because it intersects exactly at the point 5.3. Right? Because no, we established that because we can take M to be 0 and we can find the radius automatically.
Okay.
Yeah.
But
So my reasoning for this
wait, is the circle
like-
not centered at 0, 0?
It is centered at
Okay.
0, 0, and that's my point exactly, because if it is centered at 0, 0, which it is,
Sure.
examining the line when m equals 0 gives
Yes.
us that y equals 3, a horizontal line, and for a horizontal line to be tangent to the circle, like centered at the origin, the distance from the center to the line must be equal to the radius. That makes sense to me.
How would I'm just trying to visualize how the tangent line can be horizontal if it's diagonal from the origin. That to me doesn't make any sense.
Like
No, like make the
no,
circle
no,
smaller so that its radius is 3.
Okay.
Centigrade.
Like
Yeah,
like
like that.
Okay.
I believe.
Oh, I see. It doesn't it doesn't intersect at 3,5. Oh.
Yeah, no, it doesn't intersect there. It's not tangent there, but it has to be like tangent
Narowski,
somewhere.
I get you. I understand you now. I do. Thank you.
But couldn't the circle also be smaller than this though?
Well, no, because the m is limited to be greater than 0, and we cannot make a line smaller than that, no?
No, but if we make it smaller, the radius or the slope just has to be positive, right? So if we make it smaller, let's say if we made it like...
but Ram, we're saying that the slope has to be bounded by 0 at the bottom.
Yeah, but
it
can't
be bounded by
2, right?
Yeah, but it can't be bounded by a positive number. So if the circle was smaller, then this statement is if and only if, but now this is like 0.2 or something. And so it's no longer the statement we're looking for.
But m doesn't have to be greater than 0.2. It can be smaller than 0.2.
Could it be though? I don't think it could be. If the rate if this, let's say for instance,
if you have it at 0.2,
if this is a very, very small circle, watch. If it's a very small circle, right? And let's say this is still the equation of the line, right? It passes through this point. Now the restriction on it intersecting is that m needs to be positive, but not 0.
Yeah.
But we need m to be greater than 0.
But that would be the upper bound for m, not the lower bound.
No, this would be the lower bound, because then you can go up even more positive, right? And you still intersect it. The tangency is the lower bound on the slope.
Yeah, I'm inclined.
Oh, that.
Do you see that?
Okay, I see.
Yeah. Okay. So all right. So we agree that r has to be equals. I think we got it right. 2 square root of 2.
Yeah.
Yeah. Right. Yeah. Okay. And then m has to be between 0 and.
Wait.
Well, how did you get 2 square root of 2?
No, I fucked up. My bad.
Was it 3?
It's 3. It's 3. I take that back. All right,
Okay.
It's 3. It's 3.
I was
3.
like,
I don't know.
I thought I understood it.
No. Surprise. Okay. All right. Okay. Wait. What is Al just saying? Hang on. Does the line have to be?
I honestly feel like the wording of this question is like what?
Dude, Celine, come back to my chat, dude. Where are you, Celine? Celine just dropped this on us and like is causing us to like malfunction on Sunday. Sup, nerds? What's up, Psycho?
I've tutored like 6 hours today. Also.
A potential simulation says. Oh, that's Celine. Sorry, I'm taking notes. Potential simulation. Sorry, I was looking for the wrong username the whole time. Okay, it's a preparatory math sheet. I don't know if this is a prep math sheet or this is a virus intended to just like break the brains of math people.
Bing bong.
I think that's what it is.
The wording of this is just killing me.
It's killing me, dude. It's fucking killer. Okay, so we agree it's 3. And then, the minimum slope. Wait, the maximum slope. Okay,
Yeah,
we still gotta figure.
Just slap the distance formula, and it's done. Let's get this over with.
You think it's just a distance formula?
Yeah, trust me.
Between what, the origin?
The origin and the line.
But Narowski, why couldn't the slope do this? Why couldn't it be this?
Well,
because then it still intersects, right? I think we have to find this.
Yeah. So geometrically that.
Yeah.
I think this is what
Yeah,
we
but
that would make sense.
that's still okay, no? Isn't it?
Yeah, but we have to find a top end. We gotta find a top end for the slope, though.
Yeah.
Yeah. Okay.
Yeah. So.
Bears, if you want to read the problem,
it would
go here. Click on Celine's name. actualofficehours.com. Sorry. Y'all speak. What's up?
Then we have the coordinates of that point, right? Click
Do
complete.
we?
It's X. Yeah, it would be X, and then the Y would be
4.
3.
3.
Or sorry.
Yeah, this is
the
5,
R would
comma
be
3.
3.
5, comma 3. This is 5, comma 3. Right?
Yeah.
Right here. And then, okay, I see. And in order for it to be tangent, this has to happen or something, right?
Yes.
Okay,
So that's the radius.
that's the radius,
So the
which we already
coordinates
said
of
was
that-
3.
Yeah, and the coordinates of that point should be like X, and then Y would be negative square root of 3 squared minus X squared.
Square root of 3 squared minus x. Oh, okay. Wait. Because we know what this distance is, I guess is what we're saying, right? We know this is 2 root 2? No, sorry.
Yeah.
Square root of 34. Sorry.
Yeah.
I don't think we need that. I was just talking about the point that it intersects the circle,
Okay.
right? The X is just, we'll call it X.
Okay, let's just call that point x. Sure.
Yeah, and then the Y would just come from the equation of the circle, which we know is going to be X squared plus Y. We solve for Y, but we know we take the negative square root,
Good. Okay.
so it would be, because
Square
it's
root.
below the line.
Square root of 9 minus x squared? Or negative square root of 9 minus x squared?
Yeah. Yeah.
Okay. I agree with that. And then we find the slope between
then-
these 2 points?
Yes.
Okay.
But then,
But then how do we solve for
sorry,
x?
we need to represent it in terms of R. No, wait, R is over this. Wait, there's probably a way.
So yeah, this is confusing.
So, Naroski, we did find the distance.
You could.
We found this
you can
was square root
find
of
the
30.
slope of this line.
Yeah.
I figured you can find the slope of this line by doing like 3 minus, minus square root of 9 squared
Okay.
divided by 5 minus x. But it also has to be equal to the derivative of function of y. So if you,
Of the circle, you mean, right?
of the circle. So if the derivative of y is calculated
Mm-hmm.
to this,
So y equals
so
negative
y we have
9 minus x squared.
Yeah.
And you want to figure out what y prime is? So that's 1
y
half
prime
1 over square root of 9 minus x squared times 2x, yeah?
to x, and these two this expression is
Yeah.
equals to the other,
And this also equals the slope, which is
which is
3 plus
3.
square root of 9 minus x squared all over 5 minus x. Jesus. Dude, there's no way. There's no way.
Here's the thing. I don't think this is the way to solve it, but I feel like this does work. This makes sense.
All right. Celine says they can send me the answer sheet. Yeah, can you please send the answers? It just has the results. Yeah, just so we can see. I'm curious.
Yeah,
What book
so
is this from?
What
What's up, Naroski? What were you gonna say?
So what I was thinking of is like the easiest to understand method, right? So it all boils down to the fact that we have an equation for y, and we have an equation in x squared and y squared equals to r squared, but we know that r squared is equal to 9. And we already know an expression relating y to x, right? So why not just plug in what we already know about y into the second equation and just use
Oh, you mean
like
into
yeah.
sorry, into this one?
No.
Oh.
So
One
look
second.
at the problem.
Yes.
So we have an equation for the line and an equation for the circle.
Yes.
So what happens if we plug in y into y squared and 3 into r?
Oh.
Means that, okay, yeah.
Oh, okay. I like
That's
that.
the one. Oh, I forgot we had that actually.
Yeah, we
That's-
actually do have the equation of the line.
Yeah, okay. That's a lot. That's the way to do it.
See, this is the Naroski method. Okay, great. All right, this is y, and then we're gonna slam this into x squared plus y squared, right? So that's gonna be m squared x minus 5 squared plus 3. Wait. Oh,
Yep.
oh, shit. No, this is actually even more complicated than I thought it was. Damn it.
It is like
It's
I think
messy.
there's no way to make this. Yeah, there's no way
It's
to make
fucking
this simple.
gross. Ew. Squared equals 9.
God, this is
Right?
Yeah.
This is it? Yeah?
Yeah, and we just have to. Oh wait, we have to.
Wait, I gotta solve for m and I gotta solve for x though.
No, because like we have. Like we're gonna have to calculate the discriminant of this, and we're gonna have to make it greater or equal to 0, and that's supposed to give us the solutions. Right, because we have an equation. Yeah, we have an equation in x squared, and we care about m. So m is gonna be related to the discriminant.
yeah.
I see.
In
Okay,
order for the quadratic equation to exist,
Yeah.
like have a real solution, it's gonna have to be in terms of like some. That's what.
Okay.
And then if for a certain value of m,
Okay, apparently the answer is r equals 3, and the first answer is 15 over 8.
Okay, so we at least have the radius, right? Okay.
We got the radius correct. This is supposed to be 15
Yeah.
over 8, apparently.
Yeah.
wait, yeah. So we have to solve this.
This?
Yeah, I'm gonna.
Yeah.
I'm gonna quickly
Okay.
also do
Yeah,
it.
maybe just.
Maybe
do it
let me move on to
Okay.
like one of the other person's questions. And then if you guys want to like keep tackling this and just tell me if you get 15 over 8, and then we'll keep doing it. But yeah, Celine says the teacher only sent the PDF file and said to practice it. Dude, what? No, dude. This is your teacher's trolling you, dude. That's a troll.
Wait, sorry. What was the expression again?
X squared plus m x minus 5 plus 3 quantity squared equals 9.
Okay. All right. Sounds good.
All right, go after it. Yeah. All right. We're gonna put this on hold real quick. Potential assimilation. We'll come back to these. These are fun, and by fun I mean like kind of sick and twisted. But we do enjoy them.
Good job.
Just yeah. We'll come back. Let me just make sure we also have some other people. We have point slope and a circle. Yeah, totally. Yeah. Also, don't feel bad. Potential assimilation. These are very tough questions. I mean, well, they were getting kind of easy, but they're getting like this is a nightmare. And
I
you're
think
talking.
that's the only difficult one.
You think that's the only difficult one? Okay. Let me see what
Yeah,
Yeah, I
Starprod
think
had.
the rest of them.
Okay. Sorry. Let me just do this real quick. Starprod, is this an optics question you need help with?
Yeah, this is Snell's law, if I'm
This is Snell's
not
law?
mistaken.
Okay.
Yeah.
Let's try it.
I forget what it is, but I remember the name.
Okay. But wait a minute. Optics, my beloved.
No.
Oh, I see. Okay, I think I understand this. And then we're gonna have to like do some triangles. My question is supposed to be easy, bro. All right, well let me see. What is yours? Is yours easy? Find the current. Yeah, probably not too bad. I can take a look at it. But let me help out. And then what did Gladiator have? Yeah. Oh wow. Yeah. Let me do. I'm gonna do Star Pros first. Mathematician, because you're new. I'll check yours out. Then I'll do Gladiator, and then we will come back if we have time to do the fun Celine nightmare questions. They're kind of cool though. Or the nightmare question. Apparently all the other ones were bad. Okay. This is n1 is equal to 1. And then this is n2 is equal to 1.5. So we can figure out the angle at which this one escapes, right? Or here, let's another thing like this, right?
Bad.
Is it bad, dude? Dude, tell me you get tell me you get fucking 15/8 though, please. We gotta start from the other side. I think we can work backwards, Star Prod. Yeah, watch. I already thought it looked bad, Ramton, but there's got to be an easier way to do it. He's like, it's terrible.
I'm gonna
Okay.
dream of this tonight.
That's cool, mathematician. We can do that. Yeah, that's too. I love Kirchhoff's laws. They're great. All right, one sec. TikTok doesn't think I'm real. Try it again. Okay. N1 sine theta 1 is going to be equal to N2 sine theta 2 when it pops out here. And we're going to then assume, I guess... Well, interesting. So the light's supposed to bend outwards that way? I assume it's going to come in this way and then would bend out this way. I don't know how it starts bending to the right again. It comes well that's fine if it comes from the top. Okay, light comes in, it comes this way. But then when it hits something over here, right? It's gonna bend in this way, and then it's gonna bend out this way. It can't bend out on the same side.
Yeah, it's definitely not the scale, but that doesn't matter. Like,
Yeah, it doesn't matter about this. Oh, it's supposed to be on the left side? Okay, cool. That's fine. Okay, fine. Okay. Yeah. Alright, cool. Yeah, because I was like, wait, there's no way this can happen. Got you. Okay. It actually doesn't matter which way it comes. It's just like, whatever. The bottom part oh, I see. Yes. Okay, it's not the real one. Yeah, this is wrong. It should be doing this. That's what I thought. Okay, fine. Alright, so 1 sine of 35.26 will equal to 1.5 sine of theta 2. All good, Star Prod. It's okay.
I gave up on that. That became a Cortex.
No, dude.
Somehow it became a Cortex.
It's not happening today. Okay.
I can give it a shot if you.
All right. Yeah, Noski, you wanna chew on something? You can chew on that.
Yeah.
see if you can come up with if you can come up with 15/8, I will. I don't know. I'll bow down to you again, Narowski. Not everyone's on Twitch, Bear. I mean, people are on Twitch. There's 12 people on Twitch. There is 4 people on YouTube and 1 person on TikTok right now. Twitch is a better platform because it's nice and horizontal and it looks better. But Twitch just does better for exposure sometimes. Okay, theta 2. Great. Okay, so we can solve. It hits the left side of the square. Oh, that's going to be bad. Well, then it's going to bounce off. Then I got to hope it's like... Yeah, let's figure out the angle. Let's get it. Let's get it. All right, so let me get the calculator real quick. Oh, man. Yeah, I agree. I think there is going to be internal reflection. I was hoping there wouldn't be. All right, let's make sure we're in degree mode. We are. LLMs, they can. Yeah, but also subtract, or how do I say your name? SBKST? Subskip. I'm gonna call you Starburst. Forklifts can lift really heavy weights too, but you don't learn anything, or you don't get stronger from forklifts lifting things. I agree an LLM could figure this out really quickly, but we wouldn't learn anything from it. I'll call you Sean. I like that better. Yeah, okay. So there we go. So we do that. And then we arc sine. And actually, an LLM would actually probably fuck this up. LLMs don't do very well with diagrams. Okay, so this is 22.63 degrees. Sean Broski. That's a cool name. No, it's okay. So, we want to see like how far to the left it goes, right? So this is now a Pythagorean little question, right? So if we want to see how far it goes that way, and then we know that, I guess at this point, right, we know the adjacent of this triangle is equal to 9. Then the tangent of theta 2 is equal to this question mark over 9. I'm guessing... So if we do 9 tangent of that last angle, what do we get? We get 3.75.
Oh shit, not good.
Oh, fuck. So, yeah. It hits this one.
That sound effect is great.
Oh, shit, not good. My favorite one is the do not redeem one. I have that one as well. But it's like stupid loud. Wait, you're dumb? You're not dumb, Star Prod. The starting angle is 60 degrees? Oh. Well, that makes things even worse. Sorry, what? Wait, whoa. 60? Sorry. This? Are you saying this right here is 60 degrees? Okay. Alright, fine. Exactly, Bear's right, yeah. Well, the angle's changed now. The deal has been modified. We should pray that it's not modified any further, but, so, okay, so 60, sine of 60 divided by 1.5. Now I'm going to arc sine this bitch. Ugh. That gets me 35 degrees.
Oh, 35.26 was the answer.
Oh, that's theta 2. Uh-huh. Oh, I see what you're saying. Yeah, we don't need calc. You're right, we don't. I don't know why I did it. You're right. You're so right. You're right. But I did need it. Whatever. Yes. Okay, you're right. I needed it for when I divided it by 1.5, though. Okay. So theta 2 is equal to 35.26 degrees. But then, yeah. Here's the issue. Is it's gonna hit here. For sure. So, I guess I gotta figure out where it hits, right? So if this is 3, so here we can draw like a little triangle, right? This is 3, and this is 35.26 degrees. We can then, oh, this is cool actually. I already know automatically then what this angle is, right? Because it's just 90 minus, because this makes a triangle, a right triangle. So I already know the incident angle coming in. Okay, cool. So let's do that. I agree. So that's a big angle. 54 degrees coming in. I think that might be past. I think that might be the internal reflection, whatever the fuck thing. Because if we do 1.5 sine of 54.73 is equal to 1 sine of like theta 1 coming back out the other side. Yeah, let's do it. We can validate it. So 1 times the sine of this. Oh, it's just gonna be 3. Or sorry, 1.5. 1.5. Yeah, you get 1.2. Right? And there's no way that the sine of theta on the other side of this can equal 1.2. Sine can max out at 1. So that means there's total internal reflection. So then this bounces off. So your diagram actually was correct. Yes. And then I think the rule is, right, this will then, it reflects off at the same angle. I think so. Let me just make sure that makes sense. The angle at the bottom is... Oof. Yo, what's up, Green Raccoon? Thanks for the 2 euros. I hope our country still accepts those in the next couple weeks. I don't know, Trump's going crazy with Europe right now. Okay. So, that comes in, which then, interestingly enough, will then come back and hit... Oh, but we need to figure out where it hits. Okay. So I need to now know how far down it went. Uh-huh. Okay, we're gonna get that. And then and then wait, so won't this angle also be the same as this one then? And this also gonna be 35.26 degrees? Nice. Okay, cool. So here, let me just I can solve this one real quick. So this is just 1.5 sine of 35.26 is equal to 1 sine theta 2, which I think is just going to be 60 degrees again, right? Just, it's by symmetry. It's the same fucking thing. It is 60, yeah.
My man.
Yeah. This is the formal way if you want to do it, but if you're clever and you just see that this equation is literally the same as this equation, you can instantly just tell yourself this is 60 degrees. Barris says it went down 9 centimeters and hit at 3 minus. Thank you. Yes, correct. Well, okay, so wait. I feel like I want to figure out the distance here it went, and then I'll know, like, what happens next, right? So, wait, I know this is 3. Okay, so tangent of 35.26 degrees is equal to 3 over the adjacent. So 3 divided by the tangent of that nice number. So that's 4.24. Anyone here have a score of 42 on IMO? The International Math Olympiad? Is that a good score? 42? I don't know.
Yeah, I think that's a pretty decent score.
It's a pretty decent score, Narosky says. Sean, do you have that score?
I think that's a perfect score.
It's a perfect score?
It's a perfect score.
Oh, okay. So it's like whenever someone always asks me during my stream if I can solve the Riemann hypothesis, and I always get tricked. I'm like, no. Wait, it's not solvable.
Oh, one of the problems one time that was here, I was like, wait, I feel like this problem feels like a slightly harder version of some other problem that I've seen. But it was something that had like a +1 in the denominator. It was like show that a plus b divided by 1
Yeah.
is divisible. And then turns out that was the question that
Terrence Tao did?
it was on like Putnam. Yeah, that was the question.
Yeah.
Terrence Tao did.
Yeah.
And then he couldn't do it. And then I was like, okay, yeah.
Yeah, someone's just fucking with us. Yeah, Narosky explained that. And he said that, you know what's the cool thing? The person who did get that question right is now a current head of state in a country. Do you know?
Oh, wow.
So apparently the president of Romania got a perfect score on that question when Terrence Tao did not. And he's currently the president of Romania. And I was making the comments of, wouldn't it be crazy if our current president like got a perfect score on a question at IMO? Think how much different the world would be.
That's I think that was from the Putnam.
I think it was IMO is what it was. Or maybe it wasn't?
Was IMO? Oh.
Yeah.
Is it Narosky?
Yeah,
Yeah.
Yeah, I think it was from IMO. No, he didn't submit it, but he recognized it. Okay, so wait, who am I helping out here? Starprod. This goes down 4.24. So then the additional amount it has to go down is 4.76, and then you know what this angle is, so you can figure out what this distance is it travels to the right. Or actually, you know what this angle is too, right? So you could just say that the tangent. Did Narosky go to IMO? I don't think Narosky, you haven't done formal IMO, have you? But you've definitely done similar types of questions or competitions, right?
I have never qualified for the IMO.
Okay, you have to qualify for it.
Yeah.
Is that by like doing well at a
I was,
like a lower
in
competition
the
or something?
national roster. Well, there's like a whole institute of mathematics in Romania that handles this. Like we represent Romania in the mathematical Olympiad,
Okay.
right? And the way we do that is the same as like most other countries, right? We have like local Olympiads, right? We have like exams that you take in your school, and then in big colleges in your state.
Okay.
Then in like the capital or a big city, like we the qualifiers for the states meet up in one city and take the national exam, like
Okay.
the national Olympiad. If you score high enough on that, you qualify to be in the bracket for the IMO, but you are not in the IMO team until you prove yourself
Ooh.
at the Balkan Olympiads, I believe.
I see. So
Right,
there's
so
like
there are
divisions. There's
steps,
like
and
it's
I
like
have
it's like
never-
it's like city, then like country, then like region, and then eventually you compete internationally. It's crazy.
Yeah, so it's like once you get to the country stage, like you don't immediately become like a contender at the IMO. You also
Yeah.
have like steps after that, you know. Like there's an intermediary step.
That was like the one that I
At
was
the
part
most-
of also.
Yeah.
That's what you were part
Sorry.
of. You were part of the Canadian
Yeah,
one.
I was. No. When I was younger, when I was in Iran, I was part of the qualifiers to go to the IM, but then I didn't go to.
I see.
Yep.
I think you guys still will.
Yeah, those people are like cracked.
They're cracked out, dude.
Yeah, like one of my friends got in, and he like did like 2,000 questions.
To train for it, yeah.
Yeah, like he was just doing like thick, like a 600 or 1,000-page textbook of questions. I got through like 20 pages, and I qualified. And he was like, "I don't know how you qualified, but he got it." And I was,
That's nuts. Psycho says we want the adjacent. Sorry, I'm doing of the 35.26 degree one. Though Psycho 35.26 is down here, so this is the adjacent, and then this is the opposite. Yeah, I use the bottom angle. Okay, cool. All right, great. We got this one done. Bear says I played in the set world championship a couple weeks ago. I did terrible. I don't know. I mean, I'm very new to this math competition sphere. I think I mainly just like deal with kids who are just trying to like pass calculus.
Oh, yeah.
But it's very cool. I do enjoy it. No more optics for me. I'm finally free. Thank you, Star, dude. Thank you. I'm so glad to be free.
I've been one of the
Hey,
things
I
that I thought we
finished.
could.
All right, I'll check it, Narosky. Narosky finished the
No,
solution
you
for.
can say what you want.
Yeah, what were you gonna say, Ramson? And then I'm gonna move on to mathematician's question.
I was saying like, by the way, I've heard some notes like I can send you sometime during this week for the weekend of the 30th that we wanted.
Yes, that's perfect. Because then I do want to make a big announcement. I was telling people earlier, I have to. I'm gonna be out of town starting Wednesday, so we won't be streaming the second half of the week. But next week, we'll come back and do all the fun stuff. So yeah, if you already have notes and stuff, I can get that out ahead of time for the schedule, which would be great. All right, what am I doing? Oh, I need to mark this question is done. Sorry. 1 sec. Mechanics, thank God, Star. I hate optics with a passion, dude. I mean, these optics are fine. I'm totally cool with these optics. It's mainly the lens stuff that I get upset with. All right.
I only enjoyed optics as part of electromagnet.
Yeah, as part of E&M. Yeah. Narosky, what's up? What were you saying?
I was gonna say I like optics, like traditional optics. I hate E&M. That's mainly because I'm doing it right now.
Oh, I see. Yeah, so it's fresh in your brain of hate. I think when you look back on it.
Narosky, are you in university or? Oh, sorry.
He's in high school.
I'm 11th grade.
He's high schooler.
Oh,
We say he's technically a Romanian vampire because he has the math knowledge of a 500-year-old person. So, but yeah, apparently he's in high school.
damn.
My true love was trafficked to Amsterdam from Romania. Excuse me. Do you want to report something to Europol for us, Sean? Okay, mathematician here. I'm gonna help you out. You were asking about circuits. Does it work? Okay, find the current. Current in what? There's current in which component specifically here, mathematician? Because there's a couple. We could talk about the current like in this loop. We could talk about the current in this loop. Or do you want me to just solve for all of them? I can do that too. There are 2 loops. Yes. Inside of you, there are 2 loops. There's actually technically 3. Right, because there's an outer loop as well. But here, okay, we can do this loop if you want. Right. Inside. I don't see a switch. Oh, it says if we switch the second circuit, so it makes sense. I don't know exactly what this means. Make it make sense. Like what do you mean it makes sense? Maybe they're saying if we switch the battery positioning. I'm so dyslexic. It's okay. Yeah, here's one loop. And then here's the other loop. Right? And then so we're going to call this, let's call this like I2. Let's call this I1. So then I think this ends up equaling I1 minus I2. Is that kind of how we determine that? Or I think sometimes we come up with a convention for it.
This one, it actually doesn't matter. If you take it to be, if you guess it wrong,
Yeah.
you would just end up getting a negative value. So,
Correct.
So it doesn't matter. You can just guess any direction.
Oh, okay. So maybe I'll just guess this one is I1 minus I2. Well, I think I come up with another name. I fuck this up sometimes, Rampton. I think I come up and I call this like I3.
Oh, I just call it the I3. Yeah.
Yeah, right?
Yeah. That's.
What's up, Amir?
And then you just follow the Kirchhoff's law.
Kirchhoff's, yeah, exactly right, yeah. So this would be 12 volts minus 4i3. Both my loops have to go clockwise. Do they though? Bears? I don't think they have to. I think we'll take care of that in the plus minuses here when I do the loops. So if you go across, yeah. Right?
I mean, it doesn't matter which direction it goes.
Yeah. I think this is correct for the first loop. And then when we do the second loop, I would say this is 5 minus 2i2. But now I'm traveling in the opposite direction across the resistor. So this becomes plus 4i3. And then this is also equal to 0. And then
I just realized what the person asking the question was asking.
The Celine?
Exactly.
The Celine question? Which one?
No, this question with the switch the second circuit.
Oh, okay. What do they mean by switch the second circuit?
So like as it is given, I think the answer is not going to be pretty, but if you switch flip the polarity of the bottom battery.
Yes.
Like the 5-volt battery, so its positive terminal is on the left. I think you get like prettier answers.
Okay. Maybe we do. Yeah. So we'll try it. So this is as things are, but then the issue here, right, is that I have 3 unknowns. So I don't know I1, I don't know I2, I don't know I3. I only have 2 equations. So I need a third equation, and that's where the juncture law comes in. And so current in, which is I2 plus I3, has to equal current out. So I think these are the 3 equations you need to solve this. So,
by the way, do you know the whole loop thing that that goes into 0? Right. Sorry, I feel like I keep jumping in between you talking because there's a delay in the voice.
Oh, you're okay.
Yeah.
Oh, wait, you're watching on Discord, right? There's no delay in Discord.
There is a delay, and it is through Discord.
Oh, really?
There's like a 2-second, or a second delay for me.
Oh, we just gotta upgrade. We gotta upgrade your Canadian internet.
Yeah, I am going to upgrade it, honestly.
Do it.
So this thing, the loop being clockwise or counterclockwise, it doesn't matter because the law from this, like also Kirchhoff's, it says that the total, if you go in a loop, you start and end at the same point, right? So the potential difference across the same loop, because you end and start at the 0, because the potential difference throughout you should come back to the same exact amount of
You should come to the same potential. Exactly. Yeah.
Yeah. So then that's where it comes from us too.
So as an example, right, if we did make this one go, wait. If we made it go the other direction.
If you made it clockwise, everything would just be flipped by a negative sign.
Right. Yes. So then that would be I3 minus, that would be 4I3 plus 2I2, and then this would be minus 5 equals 0. And then that's the same as this, just negative, I think. Or is it?
Whenever you go in the opposite direction of whenever you go in the opposite direction of the loop, in the opposite direction of the current, in the direction of the loop, it would be a potential gain. So
this would be minus. Yeah, sorry, this would minus 4I3 plus 2I2, and then it would be minus 5. Which I think is...
that's correct. Yeah.
Correct. Yeah, got it.
Yeah, when you go in the direction, it would be a potential drop.
Yeah.
When you go opposite direction.
Got it. Okay. So then if we solve this, I always just set up a matrix is what I do. I set up some nice little matrix, which is yeah. I've just side code, for instance, I've seen some weird things where, especially when you deal with more complex circuits that have more loops and nodes and stuff, there's something about you can't just call this I3. You have to call this this minus this or something. I forget where it came from. Okay. So let's just do it this way. Just say I1, I2, I3 number, or just equals number, right? Yeah, equals number. Just plug it into Wolfram. Yeah. So yeah, let me get the matrix form of this. So that would be 3, right? If we move that over. 3, 0, 4, negative 12. This one would be 0, 2, negative 4, negative 5. And then this one would be 1, negative 1, negative 1, 0. Yeah. And yeah, I don't want to solve that. This is where I condone using basically AI, but also calculator. So 3 by 4, not too bad. 3, 0, 4, negative 12, 0, 2, negative 4, negative 5. Bears, are you a Chicago fan? What do you think of Wolfram's contribution to math? I think he's pretty dope. He's a G, dude. Yeah, he's like the alpha Chad of math, no? Or at least computational math. Give him a lot of cool shit. Then you RREF this. You know he streams on Twitch, Sean, right? He just casually streams. He's hilarious. Okay, there we go. There's our currents, which are all wait negative. Uh-oh. Did I have the wrong idea for like which way they were going? I could have sworn the 12 volt would have won. He's my idol. Yeah, he's a cool guy. Sorry, wait a minute. Did we do that right? Oh. No, I did do that right. Yeah, wait, what? 304. Your loops both gotta go clockwise. I don't think they have to.
You're not that guy, pal. Trust me. You're not that guy.
Why do we think they have to?
Wait, what? Did you get a negative value?
I did. I got.
It just means that it has to go in the opposite direction of that.
Yeah,
So
I got
which
all
one
negatives.
is
They're all negative. So like all my assumptions are wrong, which to me is kind of weird, right? This is a 12 volt source. Shouldn't current run this way?
Yeah.
Fuck. What?
That.
Fuck what?
Yeah, that's a little weird. You're right.
Yeah, right. What did I do wrong here? Let's see. Look, right? 12 volts, right? Minus 4i3. Minus 3i1. So if I put that in a matrix, that's positive 3, 0, positive 4, and then equals 12. Oh, I fucked this up. That's what I did. Oh, sorry, I fucked these up. I'm sorry.
Yeah, that was it.
Yeah. My sick brain's getting to me. Oh, all right, fine. There you go. I had my matrices wrong. I was like, wait, they can't all be wrong. That makes no sense. There we go. All right, let's do some matrix math. Now, actually, I can just go repeat this is a beautiful thing, the calculator. You just have to do it again. There we go. Okay, now they're all positive.
Okay.
Good. God is not a lie. Okay, so, beautiful. So there you go. This is I1, this is I2, this is I3. And then you're done.
Good job.
I wrote a -5 in the second equation. Did I? No. Oh, I fixed it though. Yeah. See, yeah, sorry, there you go. It's fixed now, right? Matrix looks okay, I think now.
The way to do this without pulling out a calculator would be to sum the currents leaving a node.
Yes. You mean this node?
Yeah.
So I did have that equation here, Narowski. Are there other nodes you think I should do it at?
So I was thinking. Well, no.
There's what you call like the
the
mesh
sum.
method. There's like that as well. There's that thing.
I'm not certain what that would be, but what I vaguely remember is that you can avoid like complications with Kirchhoff's law by just summing the currents leaving a node and equaling them to 0.
Yes. So, sure. There's only 2 nodes though, right? Nodes are where the wires connect.
Yeah.
So there's a node here and there's a node here.
Yeah, you've already done that. So essentially, that gives you.
That gives
one
me
equation.
the third and final equation I need in order to solve this system. Yeah, Psychode's right. The mesh method would use the nodes between batteries and the resistances, but it's the same, so the voltage drop in the resistors. Exactly. Yeah, the mesh method is more useful when things are more complicated. So let's say we start like putting like shit like here, and then there's like, I don't know, like another thing here, and yeah, that's when you need the mesh method for sure.
Yeah.
Is Matrix just used to solve a? Yeah. You're right. You're right, Narosky. This is totally a valid thing, but you also need the loop laws to solve.
Right. Okay.
You're good. Gladiator says, is a matrix just used to solve the systems of equations? No. Matrices are infinitely dimensionally powerful for doing all sorts of other stuff. It's just one of the first applications you get introduced to it as a high school student, is, yes, to solve linear equations. To solve linear system of equations. I guess you also get introduced to them. No, not really. Really? Yeah, eigenvalues, eigenvectors is like beyond high school, at least in the US. So yeah.
Yeah.
Okay. Change of coordinates. Yep. Psi codes, right? Yeah. Any like rotation. Yeah. Rotation and vectors. Yes. That matrices are very useful for that too. There's so many cool things. Yeah. Use this as inspiration for like why matrices are dope.
That's dope.
They make life easy for solving linear equations, at least systems, linear systems. Yes. Green Raccoon's right. Yeah. Linear transformations also. Okay. Does it work if we switch the second circuit? So, yeah, all that does is change the sign on this, right? So instead of being 5 minus, it becomes minus 5. Because now it's going the opposite direction. So if you wanted to, this is actually kind of cool thing you can do in the calculator. I can tell the calculator to take matrix A and store it into matrix B. And there we go. There's matrix B. And then I'm going to go into my editor here, matrix B, and I'm going to go edit that last column right here, make this minus 5. And now we're going to do RREF on matrix B. And it does make it so much easier. Wow, those are very pretty numbers, Narowski. Look at that. 2, half, 1.5. Yeah, it's beautiful. Yeah, that's much nicer. Much nicer. Let me scroll up. Very cool. I guess the what is it? The linear algebra just gets easier. I don't know if there's a physical explanation for why it looks easier. Okay, but if 5 volt flipped, you get a much nicer thing.
I may call it around here, but
You're good.
I'll definitely try to be joining more often also.
All right, you're good. You're good, Ram. Yeah, we'll be streaming tomorrow and Tuesday at least,
Okay.
and then we'll be back the next Monday. But I'll make announcements in the server.
Okay.
But yeah, forward me the
Sounds
podcast stuff you want to do, and I'll let people know.
Yeah.
Okay, cool. All right, good to see you.
All right. Have a good night.
Night night. We like pretty numbers. We do. Yes, we did it. Congrats, guys. All right, I want to go see Narowski's solution for the other one now. The circle of hell. Do I know Paul Zeitz? I don't know Paul Zeitz personally. Is he another cool math person? This was mathematician. All right, then let me mark this one as done. Albert's daily 4x4 inverse. Wait, what? Who posted a 4x4 for me to invert? That's quite cruel. Okay. Let me see what Narowski came up for this nightmare problem. And then Gladiator, I got you on the next one. So let's see. Let's pull yours in. All right, let's move this over. He's an awesome guy. Cool. What does he do, Sean? Is he a math guy? All right, let's see. Okay, so we did get to this part where we just plug the equation for our line into the equation of the circle. Okay. And we know that the radii is 3, so that makes this 9. So then you expanded this. Bless your heart, Narosky.
Yep.
Okay. And
I
then...
grouped by powers of x.
Group by powers of x. I like that. And then you said in order for there to be... So how many solutions do we need there to be for x, sorry? 2?
So we can either have it to be tangent and it intersects, or we can have it be secant and it intersects twice.
Got you. And so I want it to only intersect
So we
once then,
have-
right?
Well, no, because it asks for it to intersect at least
Oh.
once, I believe.
Oh, okay, okay.
So
Okay.
so it's intersect period. It doesn't say intersect once.
Got you. Got you. But the boundary points are where it intersects once. Is that correct though, right?
Yeah,
Right.
that's correct. Yeah.
Yeah, right? So the boundary is between like here and then like the other one's up here, I guess. Which we already proved
Yep.
one of the boundaries is 0 though. We already know that.
Yeah.
Okay. So anyways, so you say I assume this is the symbol for discriminant.
Yeah.
So you're looking for 2 real solutions. So you do that. You do b squared minus 4ac. Okay, great. You
I divide by 4 because it's
yes,
simpler
there's a
to
common
work
factor
with.
of 4. I see that. Common factor of 4. Oh, yeah, 2 squared is 4. Okay. This looks like a nice solution. Wait, no. It has to be greater than or equal to 0. Sorry. All right, wait, sorry. Oh, you factor this. Okay, you factor this. You get to
Yeah.
this. Okay. Now, wait, what happened to this? Oh, m squared minus m squared is 0.
Well, that's-
Duh.
yeah.
Okay, great. Love it. Okay, then we get to this. You expand out. Okay, now you have a quadratic in terms of m. Now you solve. Oh, that is beautiful, Narosky. Oh my god, that's pretty as fuck. Yeah, and then you get m and 15 minus 8 m. And so those are our 2 solutions. M equals 0, m equals 15 over 8. Wow. That's super cool.
It's important. It's important to notice that the quadratic sign is negative, and therefore m must be between 0 and 15 over 8 for it to be positive. I mean,
Sure. For sorry, for what? For m to be positive. Oh, I see what you're saying. Yes, I see. I was just solving it for equal to 0, and I was like, cool, the boundaries are the boundaries. But I see what you're saying. Because greater than or equal to 0, good. Then, yeah, 15 minus 8m has to be greater than or equal to 0. So you get that 8 less than or equal to 15 over, no, 8m. Yeah, good. Okay, so then m is less than or equal to 15 over 8. Right, and that's the upper bound.
Right.
Yes, and then m is greater than 0. Oh, very cool. Wow. If you're still watching, Celine, that's very cool. I mean, this is kind of... It doesn't look bad in retrospect, but I understand Ramton originally just being like, yeah. Peace. Because, yeah, I would have been like, yo, peace, dude.
yeah,
What?
It's a lot of like intuition. Like, you know, when you look at a problem and you know, like, at some point it's got to give. You know.
Yeah. Like, she's got to break somehow.
Yeah, like if you keep at some point there's got to be a solution, and it's I believe that Ramton ran into problems when he raised the polynomial to the second power. Yeah, and maybe he made some mistakes. I don't know.
Yeah. What I will say, yeah. So you have a very unique mindset here, Narosky, which is like, you know that there is a solution and you know you can get to it. I think a thing that is common amongst students, and definitely myself when I was doing math, is not having the confidence in yourself to solve it, so you think it's impossible, or you think you'll never get to it. You have confidence knowing that, like, oh, like, this bitch will break somehow. Like, I will get to it. Like, I will break down the wall. and
Yeah.
you have confidence that
Like,
you
I've
can
done
do
this
it.
before.
I've done it before,
Yeah.
right? Yeah, that's really cool. And this is also why I have arguments sometimes with some teachers where they don't see the value in like students doing like easy problems to like, or this is it. Sorry, this is what I meant to say. Sorry. When teaching, I think it's very important to start up front with like a hack or just something that just procedurally shows a student how to do the problem. And I don't care if they know why it works or like the under the hood stuff. I don't care yet. I think the most important thing is to show a student you can do this, like you can solve it. And then once they have that confidence and like they're not scared from it, then they're more willing to absorb the, okay, but why does this work? And then like, can we understand the underlying mechanics? So
Exactly,
yeah, very cool, Narowski. I like this. This is cool.
The main takeaway here, I believe, would be if you ever have like a problem where you must evaluate an inequality, especially in discriminants and quadratic equations, never, and I mean never, expand out unless it's absolutely necessary, because you would notice that I refuse to do anything with
the 3 minus
any of them
5
until
yeah,
the
the
very
3 minus
end,
5m squared. You never expanded this.
Disqualified.
Yeah.
Almost every time. I'm not sure what the reason is. Maybe it's something geometric. I haven't really looked into it, but almost always when you take the discriminant, you end up with a nice factor.
Yes. I mean, this thing just came out at the very end. Yeah. Like this.
Yeah.
This came out, and then this turned to just fucking 1. It was beautiful. Yeah.
Yeah.
Psycho says, I think we need to teach Dr. Gold that he can solve optics. You can do it. Aw, thank you. See, that's a case of like, I know I could do it, but I forget how to do it, and so I just don't want to relearn it again. But yes, this is also why I think having very good discipline and technique in doing algebra is important. I know some of this seems, I don't know, trivial, quote unquote, or like boring or monotonous, but it's very powerful, because I can't tell you how many times in grad school I would be going through some sort of derivation like this, and it's like 2 or 3 pages long, and the silly algebra mistakes you make along the way just like,
Surprise, motherfucker.
they just fuck you, and you don't get these beautiful, elegant solutions, and then you end up just hating yourself.
And like, this is the worst part of math to be in. Like when you're still getting it down, like getting these tactics down. I believe this is the worst part to be in, because you cannot look anywhere for help. The only help you have is like working extra and bashing your head against the wall until you get it. Because a computer is just gonna say like, yeah, dude, it's equal to like this. Like, how can you not see it?
Yeah. It's like the solution. It'll just be like, oh, this is the solution, and it, I'll leave it as an exercise to the reader that you should know how to get it or something. I guess nowadays though, I think with ChatGPT, I'm pretty sure we could say explain step by step algebraically, and I think it would show this. But back in the day, no, it would never do this.
Yes, but the way I believe like ChatGPT would do this is just it would expand everything out, or like it wouldn't look for things like this. Right, so
I see.
It still has like computational power that we don't have.
Sure.
Like
but it brute forces it.
You can't just expand. Yeah, exactly. You can't just think like, okay, let me expand everything, and I won't make absolutely any mistakes in expanding page long.
Yeah, this was smart not to expand these. That was smart. Again, because you've done it before.
You notice, you notice that you have m squared and you have a quantity squared of m. So eventually you get to a quadra, like what did Rampton say? He got to
a quartic.
Powers of 4.
Yeah,
a quartic. Yeah.
Damn. Okay. Cool. Nice. Potential. If you hang around, I'll do your next one. But how about Gladiator? Because he's been waiting for a little bit, and we're gonna do some physics. This is fun. I like this. Mass specs, actually. These are cool. And then, potential. If you're not already, I highly recommend go join our Discord. So the website's here, actualofficehours.com. And you click here on join our Discord. And any of the solutions that we go through, I will post them into our Discord server. So you can, little download the PDFs and just look at them. I'm working on a bot that when we do a question, it'll also post what timestamp of where in the stream it was done. It's one of my projects to do next. One of my little vibe coding projects. Okay. Where was it? Okay, this is your question. Did I not paste it yet? Okay, that was that one. That was that one. This was this one. Okay, let's do this. Okay, mass spec and analytic and yeah, blah blah blah. Q over M. Okay, there's so many words. What? I want to read all these words. Okay. All right. I like the picture. The picture's really cool. And I assume this magnetic field is coming out of the page. Do they say that? Sometimes I'll just like skip over all this and I just want to see like what's the first question. Okay. To 5 sig figs, what accelerating potentials delta V are required to detect the ions O2, N2, and CO2 plus? The mass of the missing electron is less than that is not relevant. Although N2 plus and CO2 plus both have nominal molecular mass of 28, they are Englishly distinguished by virtue of their slightly different acceleration constants. Use the following things. Okay. Did someone say chemistry?
Good job.
Dude, yeah, say chemistry 4 times. There is a chemistry ion here. Okay. I see. This figure is not related to what we're doing. Yeah. Okay, so here's what happens is, yeah, they accelerate these things across a potential here, because these things have a positive charge on them, and this is a negatively charged plate, and so the negatively charged plate will pull the positively charged thing towards it, and then there's a little hole here, a little slit, and this slit allows the ion to rocket past it. But then once it's here, it's in the presence of a magnetic field. And this is where things are cool. So there's a thing called the Lorentz force, I think, which is F is equal to Q V cross B. And so this says the force on a charged particle Q is equal to the velocity crossed with the magnetic field. In this case, when it first exits the slit, this has some velocity pointing to the right. Magnetic field is pointing out of the page. That's what this means. If they were this, they would be pointing into the page. So this is magnetic field coming out of the page. And then if you use your right hand, because this is a positive charge, we're okay. V cross B means that the force acting on this thing, the second it gets out of the gate, is down, okay? So this force is going to act down right when it's here. So the force will cause it to change the direction of its velocity. It wanted to go this way. Now the force is going to like kind of turn it a little bit downward, so it's doing this. And it's a little bit further out. Now when you calculate the force on this one, V cross B, you're going to end up getting that the force is pointing this way. And so what happens is this particle continues to be pulled in towards some sort of radii, and it's very similar to what's called like centripetal motion. Like when the thing's out here, when the thing has eventually started moving downwards, now V cross B, if this is V, B's still out of the page, now your force is this way. And so this is why a charged particle will now move in a circular path. And so what they do, when they're doing some sort of like spectrometer type thing, is they know the distance. How much money can you make doing this? I mean, if I was charging people, you could probably make like 100K. But I don't. This is free. I do have a PhD. But then you'd also have to like market yourself and stuff. It's a whole thing. this detector is located a distance d down, and there's like another slit here. So based on how fast this thing is moving, we'll determine what the radii of this orbit is, and you need the radii of this orbit to be half the distance between the slits, right? Because the radius of the orbit is like the halfway distance. This is kind of like, this is the path it follows, right? So this is r. So there's actually kind of a cool way to do this. So if f is, get rid of the cross products, just assume, right, the direction is pointing directly inwards, is equal to qvb. That's also equal to ma. Force equals ma, right? And it turns out that that force from the magnetic field is the same as a centripetal type of force. So there's a centripetal acceleration. So instead of saying a, you end up saying ac, which is going to be mv squared over r. Okay? And now you can set these two things equal to each other. This is called like cyclotron radii or whatever it's called. Or Larmor radius, maybe? I forget what it's called. So mv squared over r. So then one of the v's cancels. And you end up getting that r is equal to mv over qb. This is a very, very famous equation in physics, E&M stuff. So this, and I believe this is called Larmor radius. Yes, exactly, because they're always, yes. Yes, Larmor radius is mv over qb. Yeah, it's also, yeah, cyclotron motion. This is kind of another cool diagram for it. And then cyclotron frequency is a measure of like how much it spins around it, and that's related to the radius and the velocity, so you could solve for that as well. Okay, and then so we know r is going to equal to d over 2, so you have that d over 2 is equal to the mass of my thing times the velocity over qb. Great. And I think what they wanted to know eventually, is what is the accelerating potential needed. So interesting. So they want to know what's the potential between these two plates. Now, how's that even related to my question? Well, my question here showed that the relationship between where the detector is, right? That's d. The velocity that it's initially entering the cyclotron motion, and then mass and magnetic field and charge. So the thing that's going to change with a different potential is what the initial velocity is coming out into the magnetic field. So I can rearrange this to say, okay, dqb over 2m is equal to v. And this is like the initial velocity out of the slit, which is also equal to the final velocity between the plates. Because we also have this situation where, okay, we're saying this is at a positive potential, and then I guess technically there's a slit here. It's a negative potential. And I want to know what the velocity of this this positive thing is after it's moved across the plates. That has to do with the change in potential energy is equal to the change in kinetic energy. So when the thing is originally here, you assume it starts at rest. It has 0 kinetic energy. What's up, yo? And it has unlimited potential energy because it's next to it. It doesn't want to be there, right? So the change in potential energy, this is equal to Q delta V. You learn this also in E&M. So charge times change in voltage is change in potential energy, and that's going to be equal to the change in kinetic energy, which is 1/2 m v squared. These are two different v's. Let me call this phi, maybe. Seems better, right? And then we're going to keep this as velocity. Because now I have an expression for what the velocity would be once this thing starts exiting, okay? So I would get that v is equal to 2q, we can say, let's just say phi. 2q phi over m square rooted. Yeah? And then that, we can then substitute into here. I forget, what the fuck were we even trying to solve for? Find the potential. Okay. Okay, so I'm doing everything in terms of variables, just because I hope things like cancel at some point. Maybe they will. dqb over 2m is equal to the square root. Oh, did I fuck up? 2q phi over m? No? No, yes. Oh, it's okay. You're good. It's okay. Alright, so from this, I'm trying to solve for phi. We want the potential. I'm going to square both sides. Yeah, yeah, v and theta. Yeah, v and phi. Yeah, I'm using phi's potential. Squaresies. So you get d squared, q squared, b squared over 4m squared is equal to 2q phi over m. Okay, so one of the m's will cancel, which is nice. Good. One of the q's cancels, which is nice. And then that's going to become that. Okay, so phi is equal to d squared b squared q over m over 8, I think. D squared. Okay. So, do you have any of the answers to this, Gladiator? Because at this point, we're just plugging in numbers, I'm pretty sure. But I would like to, like, plug in one set of numbers to make sure it's correct. Because sometimes I can get this wrong. Yeah, let's see if you have an answer for it. Just because they're doing weird things with the ions. Okay, so let's see for the first one. Okay, so first of all, D is already given, right? D is an 8, so D is equal to 0.08. B is equal to 0.2 because it's 200 milliteslas. And then Q is going to equal to 1.6 times 10 to the negative 19. Because each of these ions is a +1 charge, which means it has 1 unit of charge. And a unit of charge is 1.6 times 10 to the negative 19. Okay, good. So that's what we're looking for. So we're looking for 193 volts. Yeah, if we get that for the first one, I'm just going to call it. So O2, I think O2 has a mass of 32. Can we just say that? I'm pretty sure it is. Yeah, 31.99, whatever. Yeah, okay. So M for O2, so is 16 plus 16, so that's 32 atomic mass units, but then this is times 1.66 1 times 10 to the minus 27. Okay, so let's plug stuff in. Let's see if we're correct. I want to say yes. Okay, so 0.08 squared times 0.2 squared divided by 8, and then times 1.6 e to the negative 19. Great. And then we're going to divide that This gets divided by the mass, which is 32 times 1.661 e negative 27. Okay. That got us 96. Fascinating, because that's half of what we need. Yeah, if I multiply by 2, we're good. Oh, man. Oh, yeah, I know where I fucked up. Wait. No, actually, I don't know where I fucked up. Sorry. This is 2. I divide by 2, that's 8, right? Yeah, it should be 8. You got the same formula? Yeah, right? But our answer is half of what it should be. Now, here's an interesting thing. They say, yeah, N2 and CO plus, the mass of the missing electron is less than that. Is not relevant. Although they have nominal molecular mass of 28, they are easily distinguished by virtue of their different accelerating voltages. Exercise 29 for atomic masses. Sorry, what? They have different masses. What? Yeah, N2 is 28. Oh, carbon monoxide is also 28. Fascinating. Wait. So wait, how do you get different numbers then? I would think that answer choice B and answer choice C should be almost exactly the same, right? Unless I'm missing something. Kato!
Good job.
Rocket League champion. Yeah, B and C should be the same. Yeah. The question we're doing, it's on here. It's cyclotron stuff. It's actually related to chemistry. It's a mass spectrometer. Yeah, I don't know what I did wrong. Maybe it has to do with the distance. Yeah, R is D over 2, for sure. I think we're fine here, right? 1/2 mv squared. 2q5 or m, yep. You know what we can do? We can throw it in ChatGPT. See what it gets. It'll tell me what I did wrong. This is where chat's useful. I'm off by a factor too, so I know I'm not crazy. Oh, we were trying to solve for the potential needed for O2 plus. Which I think I got. Wait. He says, wait. Z effective. I said the mass of O2. Isn't the mass of O2 is 32, no? Right? Oh, wait, yeah, because oxygen... Oh, I fucked up. No, O2 is 32. Wait, no, O2 is 32. They said O2 ions. Wow, ChatGPT also gets it. Yeah. ChatGPT also gets 96 volts.
Good job, good job.
I think the textbook's wrong. No, I think I'm okay. Textbooks can be wrong. It happens. Yeah. This should be 96 volts. I don't think it should be 193. Yeah, textbook's wrong. Okay, cool. Does that make sense, Gladiator? How we got that? And then yeah, CO and NO would be the same. Or N2 and CO. Yeah, cool. Alright, great. That's a fun question. I like that one. Yeah, you're very welcome, dude. Alright, let's see. Oh, man. Yeah, there's energy conservation, a little bit of E&M. There was also centripetal motion acceleration. Yeah, this is a great physics question example because it kind of combines everything you need to know, right? Yeah, we had energy conservation, we had E&M, and then we also had mechanics. This is why I like physics because you have to put together all the different like building block things, you know? I will say one of the things I get kind of miffed with in chemistry, right, is sometimes the subjects are all very detached, you know? Like, figuring out electrochemistry doesn't necessarily relate to thermochemistry or whatever. Or, like, you know, you learn one technique. I don't think you really use it in other techniques, right? Yeah, he's fuming.
Disqualified.
I do love chemistry. I mean, this is also the reason I don't like biology, because biology is all separate. I know it should technically be all unified, but biology is just, like, all over the place. Yeah, the theory behind mass spec is something I haven't learned, which is all. Yeah, exactly. Yeah, they're very cool, actually. Yeah, and again, it's a physics concept. It's just a physics, you know. Did you know about this, Kato? I'm sure you did when you took physics. You know, positive charges going through, you know, magnetic fields like curve. I'm sure you've seen that at some point. I like biology. Biologists don't even understand biology. Yeah, they don't. Okay. All right, let's see. What else we got? Okay. This looks like a fun one. And then Celine, I'll work on the last two of your other one. This should have updated. There we go. Oh, it's for electrochemical applications? Yeah. We're going to do the Celine ones in a second. I'm doing this new one that got submitted from somebody, which looks a little tricky. Something about roots. Oh, man, what's the theorem with, like, roots? Some rule to this. You want to talk about Naroski?
Yeah, I do.
Okay.
So what does this say?
It says the quartic equation has roots alpha, beta, gamma. I don't know why they just didn't say A, B, C, D, but whatever. Oh yeah, my evening show's on. What's up?
Oh yeah.
Mathematic fanatic, dude. Once in A level, they taught us two different ways that water travels in plants. Then they told us they were both wrong, and they needed to memorize why they were wrong. You just woke Naroski up from his 500-year sleep. Oh, man. Yeah, Kato, there's no right way. Okay, so let's see. Find equations with integer coefficients. So this is going to be some Diophantine stuff, no?
No.
No? Okay. I saw integers. I was like, Diophantine.
My instinct here is... Oh, so it says Oh, perfect. So we have roots 3 alpha, 3 beta, 3 gamma, 3 delta. They all have the same coefficient, right?
Mm-hmm.
So we would have a new equation in a variable, let's say variable y,
Okay.
and we want the roots, right? The 4 roots of the quartic to be 3 times the original roots. And how do you see
Oh, I see. So yeah, so root x is equal to like 3 alpha. So a new root would be y is equal to x over 3? Or no, x
Yeah.
equals 3y.
x equals 3y?
That's what I wanted to say, sorry. So you want me to replace these all with 3 y's? So 2 times 3y
Oh no,
to the...
wait. Wait, no. It was okay the first time you said it. Like
Oh, it was the
execute
first time?
all of it. Yeah.
Okay.
Because like you want them to be 3 times like the new roots.
Yeah, sorry, these are the roots. And I want... Yes, okay.
So yeah, so expect like they are the roots to the equation, and the new roots have to.
I
be
shouldn't be using x. Sorry.
Yeah.
Let's just say y. Y equals 3 alpha. So y over
Yeah.
3 is equal to alpha. Okay. Okay.
Yeah.
Which is the same thing as x. Okay, so yeah, so that's 2. And we say like y over 3 to the 4th
Yeah.
plus
so
4. Yeah, y over 3. Now, do I want to expand yet? Or should I wait? What's your intuition say?
Yeah, I don't think there's a point in not expanding.
All right, let's just expand.
Yeah, I think this is basically what it's asking. It's like expand this and like see what happens.
Okay, see what happens. So 3 to the 4th is 81, right? So this is 2 over 81. Y. I'm going to leave it like y to the 4th. Plus 4 over 27. Y to the 3rd. Minus 5 over 9. Y squared. Plus 2/3 y. Minus 1 is equal to 0.
Yeah.
I see a bunch of factors of 3. Yeah. Should I multiply everything through by 81?
Actually, powers of 3. Yeah. The reason we are multiplying by 81 is because we want integer coefficients. So we have integer. Yeah.
Let's do it. I agree with you.
Because
Multiply
that's
this all by
basically what
81.
that's basically what it's asking.
Okay, so now I get 2y to the 4th plus 12y to the 3rd minus 45y squared plus 54y minus 81 equal to 0?
Minus 81. Yeah.
Okay.
And yeah, this is the
54y,
equation.
And we just gotta solve this?
No, this is the equation.
Oh, okay.
So yeah, this is the equation that has 3 times the roots.
Oh, this is just find the equation.
Good job.
Oh, okay. Okay. Well, that one wasn't so bad.
And the same concept is for B.
So this is x plus 1, right? Is that what you were gonna say?
Yeah. So yeah, implies let like I don't know z equals x minus 1, and therefore x is gonna be.
So x equals y plus 1?
Yeah.
Okay. Well, this is ugly now, though.
Huh?
I don't like this.
Yeah, this is gonna be like a lot of calculations.
I don't want to do this.
Yeah, I don't think there's a way around this.
Oh no. Okay. I'm gonna leave it as an exercise to the reader. Just because I don't want to expand a quartic, dude. That sucks.
Yeah. This is where computers are useful.
Yes. This is where the clanker comes in handy. Yeah.
Exactly.
Okay. Nice.
Yeah.
Yeah. Okay. Cool.
And-
So there you go.
Notice how they are all powers of coefficients of y, and you're gonna just group by powers of y.
Yes.
Yeah.
Expand and group. And that's how you would do that one, Albert. Great job. Okay, not so bad. It looks scarier than it was.
Yeah, you just have to understand.
Nice.
That's actually most of math.
That's actually just most of math. Okay, let's see like what Celine's other questions were. So I got 20 minutes.
I did go through a few of them.
Okay, are they tricky?
It's tricky to explain on paper. Like verbally, I don't think it's as tricky.
Okay, so let's.
Yeah.
Let's. I don't know. We've had like a lot of stuff going on.
Yeah.
I feel like, dude, this whole fucking question 4 took like the whole page to go do. So I think I'm gonna move it around. Okay, that's gonna be there, and then here we're gonna take this, put it somewhere else. We aren't sure how sap flows through phloem. I remember those words. Xylem and phloem from biology. I remember that. Biology is just stamp collecting. Okay. I don't know why that got all weird, but okay. Okay. And then we'll eventually get to these, I guess. Okay. When x, the absolute value of x, okay, so when x is between negative pi over 2 and pi over 2, the maximum of sine of x plus cosine of x is, and the minimum is, ooh, this is cool. Do I want to like set up a derivative, you think?
No. Why would you do that? No. So,
I was going to like find the critical points.
So sine x plus cosine x.
Yes.
You know how you can switch sine and cosine, right? By adding or subtracting pi over 2.
Yes.
So let's think in terms of sine x, right? So how would you transform cosine x into sine x?
Cosine x into sine x would be sine of pi over 2 minus x. Right?
So yeah.
I think cosine of x is equal to sine of pi over 2 minus x, right?
Yeah.
Okay.
So how would you turn the cosine into sine?
Oh. I would just replace it, no?
Yeah.
Okay. So sine of x plus sine of pi over 2 minus x, like this? Equals something?
Yeah.
Okay. Do I want to, is there a formula for this?
Yeah. Do you know the formula for summing up to...
I think it's sine A, sine B minus cosine A, cosine B? Or is that cosine?
So it's 2 sine A plus B over 2 cosine A minus B over 2. Does it sound familiar?
It sounds familiar. I have to remember it. Fanatic. Yeah, see, Fanatic's doing what I would have done. I would have just busted out calculus. But I get it. This is for a prep school, and I don't think this student... Well, wait a minute. This last question we did definitely needed calculus, did it? Didn't it? For this one? The tangent line? That needed calculus.
I suppose.
Yeah, but I like your solution better. All right, well, this is cool. Yeah, all right. Where's it? Sum of sines equation, or whatever it's called. Oh, sine A cosine B. Not this one.
No, not this one. Not this one. Sine A plus sine B. So yeah. The second one.
Ooh.
The second one.
Oh.
Yeah.
Oh, this is wicked.
So transforming,
what?
transforming a sum of trigonometric functions into a product.
You see, I was gonna expand this one out, but I like what you're doing. It's the reverse, basically, right?
Yeah. I just want one trigonometric function, right?
Are you gonna get one though? I feel like you're gonna get 2, or maybe not. We'll see.
Just wait.
Okay, just wait. He's like, wait for the magic, dude. Okay, so this is 2. So we're doing this one.
Yeah.
So this is 2 sine of x plus pi over 2 minus x all over 2. Oh, I see what's gonna happen. Naroski. Oh, I see. That's cool. And then this is cosine of x minus pi over 2 plus x all over 2. Yeah.
Yeah.
Well, look what happens. X minus x is 0. So you get pi over 2 divided by 2 pi over 4. So you get 2 sine pi over 4, which I know what pi over 4 is.
Yeah.
And then this is cosine of 2x minus pi over 2 all over 2. So that's
So which-
x minus pi over 4?
Yeah.
Okay. Ah, beautiful. Because then this is 2 square root of 2... 2 square root of
No,
2
just
over...
square root of 2.
Or just square root... Yeah, 2 square root of 2 over 2. So it's just square root of 2.
Yeah.
So square root of 2 cosine of x minus pi over 4. And then x is on the domain of... Did they say negative pi over 2 to pi over 2?
Yeah.
Cool. So yeah, where's the max happen?
Yeah, we have to think where the maximum happens.
We do have to think
Well,
here.
The maximum is the easy part, right?
Yeah.
Because you have the square root of 2, which is greater than 1, multiplied by a trigonometric function. And what we know about trigonometric functions is that they are between -1 and 1. So at
Correct.
most, it's going to be equal to 1.
Yeah, but it won't even get
now-
there though, right?
yeah.
Because there's no way this can get to pi over 2. Or it can't get to 0.
Yeah.
Sorry, it can't get to 0 to pi. Or maybe it can? Oh, it can actually. Sorry. Wait, I'm retarded.
Yeah.
Sorry.
Yeah, you can.
Yes. This is a max when you have cosine of 0, right?
Yeah. So exactly pi over 4, it's maximum.
Which is equal to square root of 2. Okay.
Yeah.
The minimum, though, yeah, that's a little bit more confusing.
So the minimum, you either graph it out, like if you know how to graph trigonometric functions on paper,
Yeah.
or you look at the endpoints of the function.
Yeah.
So what I would do is I would evaluate at x is equal to negative pi over 2, and then at
Yeah.
x is equal to pi over 2, and see if a change of sign happens.
Gotcha.
Right.
So cosine at negative pi over 2 would be negative 3 pi over 4. So let's say evaluate endpoints. And negative 3 pi over 4, that's equal to negative square root of 2 over 2, right?
Yes.
Okay. And then cosine of pi over 4 is equal to square root of 2 over 2.
Yep.
Okay. So I think this is the minimum.
It looks to be the minimum, yes, because
Because nothing
it's
can be
going
more
to
negative than
be-
it.
Yeah.
I'm just thinking graphically,
So
right?
Yeah. So thinking like you'd graph it and like
Like
it's going to be increasing.
Yeah, cosine is the
Yeah.
adjacent, right? Well, I like to think of it in terms of the unit circle. Right? Cosine's the adjacent. And
I think it's more helpful to think of it as a function instead of like a unit circle.
okay,
in
we
this
can think
case.
about that too. Let's do that too.
Yeah.
So you're thinking like
Yeah, so
doing
it's
this way. This is like 1, right? And then this happens at
Yeah.
negative pi over 2.
Actually, negative pi over 4.
No. Oh, I'm not graphing the shift.
Yeah.
I'm just graphing like what's inside
So-
here.
Oh, okay.
Right.
Right.
You are right though. And then this would be positive pi over 2.
Yeah.
Because there's
In
no
any
way
case, yeah.
for this thing to go to positive pi over 2 because it's minus pi over 4. So you already know
Yeah,
that
and-
you can't be here, right? And then the shift, the shift causes it to like. Can I move the shift? Can I move it? Like that? I think. Well, it's kind of like that, I guess. Yeah. What's up, Bedlam? I see. So yeah, the more left you go, the more negative you're gonna get, anyways.
Yeah, the thing is, it's gonna be increasing up to pi over 4 anyways.
Exactly. Right. Yes.
Yeah.
Okay. So this is the minimum.
Yeah. I do have a graph for the sign of it.
Oh, you do?
So, yeah.
wanna drop it in?
Yeah, one second.
Alright, so the maximum is equal to 1. Oh, sorry, square root of 2. The minimum, negative square root of 2 root 2, so it's just times square root of 2 is just negative 1? Wait, is it also negative 1?
Yeah.
Oh, beautiful. I like this. This is cool.
So yeah, we did 2 different approaches and we got the same.
Beautiful. Nice.
Good job.
That's also, that's a really cool thing in math. When you do 2 different approaches, get the same answer. Nice. Okay. So then this is negative 1. Oh, cool.
Yeah.
Sick. Okay. Let's do this one. Still got 10 minutes.
Sure.
I'm learning. Learning's fun. Okay. By log base 10 of 2, sorry, is equal to that. Log base 10 of 3 is equal to that. The number of digits of 6 to the 100 is what? And its leading digit is what? Oh, man.
So yeah.
What the fuck is going on here, dude?
So this is basically like relating logarithms, log base 10 with the number of digits. So the way this works is like you know how you would write a number like to the power 10 to the power of something to know how many digits it has, right? So 2 is basically 10 to the power of 0.
Okay.
Yeah.
What's up, Shaq? Right, and then 10 to the 1
digits,
is
yeah.
wait.
How many digits, like how many digits does 2 have? And it's gonna be 10 to the power of 0 because it's 10 to the power of the integer part of its log base 10 logarithm, right? So
okay, wait. 10 to the 0 has 2 digits?
No, has 1 digit.
Oh.
So it's
1 digit,
so it's
yes.
Right.
Got you. 10 to the 1 has 2 digits.
Yeah.
And so forth and so forth. Okay, good. What's up, Sean?
Yeah.
Okay. Oh, and we want to relate this by a log, is what you're saying?
Yeah.
So I could say that log base 10 of 1 is equal to 2, kind of ish.
So no, you can look at like log base 10 of 2. It's given to you, approximately to 0.3010, right?
Okay. Yes.
Yeah.
JC says something about standard form.
So yeah, it's kind of like that. Yeah. Like you'd think of it like
oh, I see. Wait.
How many digits? Yeah.
So wait, so 10 to the 0.301. No, sorry, I'm not getting it. Keep saying things, Narowski. Sorry.
Okay, so what would be the integer part of log base 10 of 2?
0.
0, right. And of 3, also 0.
Uh-huh.
So how would you write 2 in standard form?
2 is equal to 10 to the 0.301. Is that standard form?
Integer part. So standard form is
Sorry, what's standard form?
like, so it's like
You mean scientific notation?
Yeah, scientific notation. Yeah.
Oh, okay. Like that? Wait, no. Sorry,
Oh.
dude, what the fuck am I saying, dude? Sorry. Log base 10 of 2 is equal to 3.01 times 10 to the minus 1. Yeah? Does that look better? Am I getting closer?
Yeah.
Okay.
Yeah, you're getting closer, right?
Getting closer. We're getting closer.
Now 2 is equal to 2 times what power of 10? Right? Think of it like that.
2.
2 is equal to 2 times 1 practically, so it's just 10 to the power of 0.
Yes. Yeah, okay.
Times 2.
Times 2.
Right.
Okay.
So how many digits does 2 have? It has 1 digit, so it has 10 to the power of 0 digits.
What?
Does that make sense?
No.
Okay, how many digits?
Whoa. You just said 2 has 0 digits, which means it has 1 digit? What?
No, so 2 has 10 to the power of 0 digits.
Yes. 2
Right.
has 10 to the 0 power digits. I agree with that. It has 1 digit. Yes.
So it has 1 digit, right? How
Yes.
many digits would 20 have in this case?
20 would have 2. Right?
20 would have 2 digits, right?
Yes. And then, so what did I do? I just multiplied both sides by 10, right? So 2 is equal to 10 to the 1 times 2? Is that what we're saying? That's 2 digits? Oh, maybe I'm not seeing it. 20, sorry. That's what I meant to say. Where are the logarithms coming into play here, dude? I'm waiting for the logarithms.
Okay, so what would the log base 10 of 6 to the 100 would be?
Let's do that. Look.
Yeah, that's...
All right. JC says if a number can be written in the scientific notation of a times 10 to the n, then there will have n plus 1 digits. Okay.
Yeah, exactly.
I see.
trying to
20 is equal to 2 times
realize.
10 to the 1. It's this plus 1 digits. I see what you're trying to show me.
Yeah.
Okay. I think I was a little bit confused
Yeah.
about this.
And we're gonna see how logarithms play into this.
All right, let's do it. Okay. So I'm going to say log base 10 of 6 to the 100, right?
Yeah.
Okay.
So just pull out the 100.
That's 100 times log base 10 of 6. Oh, I see. And you want me to combine these. I feel you, dude. I got you, man.
Yeah.
I got you, dude. Okay. So that's 100 times the log base 10 of 6. Or sorry, 2 times 3. Or 3 times 2.
Yeah.
Which is 100 times the log base 10 of 3 plus the log base 10 of 2, which we said was
And we know their
0.30.
values.
Pardon? Yeah.
And
we know their
their
values.
values, right? So,
Okay. So that's 100 times 0.301 plus 0.477. Okay.
sure, yeah.
So that's 0.77 times 100. Oh, I see what you're going to do here. Which is the same thing as 10 to the 2, right? Which is the same thing as 7.7 times 10 to the 1. Wait, did I get there? Did I fuck up? I think I fucked up.
Well, no, we're not at that point yet. We're still dealing with logarithms.
Okay.
Right
All right,
now,
we're still doing
right?
logarithms.
So
Sorry.
we're still we're still doing logarithms.
Okay.
We just want the value of log base 10 of 6 to the 100th. Like we want the exact value of that.
Okay. So,
Right, so it's just gonna be 7, like
7.7.
let's say.
Yeah. Okay, I got
77.
you. 7.7. Yeah, 7.78. Yeah. Okay. That's equal to.
Not 7. Wait, not 77.
Isn't there a 1 here and a 7 here?
Yeah, but are you not multiplying by 100?
Oh. Wait. Oh, 77.8.
Yeah.
Oh, yeah, you're right. Sorry. I'm getting tired.
Yeah.
Okay, 77.8. Yes. It's
Yeah.
the log base.
Okay.
Is the log base 10 of 6 to the 100, right?
Yeah.
Okay.
So now, right? So if you would,
Oh.
get rid of
I see. So 78
Yeah.
digits?
70 digits.
Okay, I didn't know this property. That it's always the n plus 1.
So
I didn't know
take,
this.
Yeah, you take the integer part, like the floor,
Uh-huh.
and you add 1.
Yeah. Mathematician, did you answer my question? We did answer it. Big dog. Big cheese. If you join our Discord, we did the answer right here. here was your question, and then here's the solution. So yeah, make sure go join our Discord, and it's in this channel called Homework Help. It's also gonna be on the VOD. It'll be recorded. Magnus, what's up, dude?
Yeah.
How's it going, brother? Could you explain it to me? Well, not now, because the stream is about to end in 20 seconds. But you can watch the recording, because I did do it, and I did explain it to the audience, but I guess you weren't here, unfortunately. But if you want to watch the recording, it'll be on there, and the solutions there as well. Yeah, you're very welcome. Magnus says I have a physics problem. I have to go, unfortunately, Magnus. But if you want to throw it in for tomorrow's stream, we'll definitely do it. Oh man. Okay. Yeah. I need to go like rest and like go eat some soup or something. But I appreciate doing all these questions with you. They're really fun. Let me put Celine's solutions so far from what we did on this. These are very cool, Celine, by the way. I really enjoyed them. Oh, you're looking at the solutions and they didn't take D = 2R? Yeah, they're wrong. For sure. I have math too hard. That is true. Okay, Celine, I'm gonna put this in for you. So yeah, make sure to join our Discord, Celine, so you can go see it. Also, you get credit and points if you answer questions or ask questions. Okay. Yeah. Good. Yep. Again, the website's right here. Let's close out the stream. Cool. All right. All right. Thank you everyone for coming to Actual Education Office Hours today. Appreciate everyone's help. Y'all in the audience, always great. I appreciate all the suggestions. I learn alongside you guys. That's why I really enjoy this. Like if this was my full-time job, I'd be like, I never have to work a day in my life because I'm doing things I like. It's fun. Thank you, Ryan Gosling. Yeah, good night to everyone. Yeah, I'm gonna rest up. Yes. So that being said, make sure you go to our website, actualofficehours.com. Join our Discord. Find out about the cool stuff we're doing. We do activities all the time. And click here on the streaming schedule, because that will have the most up-to-date schedule of when we are streaming next. So we are streaming tomorrow, same time on Monday. So that'll be 5 p.m. Pacific, 6 p.m. Mountain, 7 p.m. Central, 8 p.m. Eastern. Something else across the pond internationally. And then there are a bunch of other cool people that are streaming. So make sure to go check them out. They're all our friends. We love them. They're awesome. Jake Gyllenhaal. I do get called Jake Gyllenhaal sometimes too, actually. Maybe not anymore, but... And yeah, if you found us on YouTube, make sure go follow us on Twitch as well. It's a better platform for the community and stuff. YouTube is unparalleled in getting new people to see our stuff. So is TikTok. But I really like the community aspects of Twitch, so we just funnel you guys in there. And if you are watching us Twitch, we're going to go raid another channel, which is where we go show our support to someone else who is streaming, hopefully Math or Science tonight. Let's see who's on. Arc Raiders, High Potential. Everyone's just playing games. Well, go say hi to... There's always Science. Science is... I met Belint. He's a cool guy, but they do this full time, like 6 days a week. They're nuts. So, yeah. X is unparalleled, so is Y. Oh, yeah, well, I guess they parallel each other. Okay, cool. All right. Thank you, everyone. Enjoy the rest of your weekend. We will see you tomorrow. So, have fun. And peace. Thanks, Roski. Peace out.
Zay, the camera's been sneaky to me with me tonight. Sneaky. Actual Education. Welcome in. Oh, I froze again. I can't welcome you with a freeze. Hold on. Hold. There we go. Welcome in, Raiders.
Science stream, but we ain't bugging. We over here about to leave. You be chugging what we got. Now the tracks arrive. I promise that I have prescribed you.